Two in total.
Two already enrolled.
Well, and some on the pictures. Technically, one is not necessarily a robot. Can anyone fold a paper plane?
Sorry?
If anyone can fold a paper plane. A plane from a paper, if anyone has the skills.
Yes. Yeah, we're waiting 5 minutes. Give everyone a chance to coffee.
There was a whole session at the FOSDEM in Brussels, but not on the not robotics, but like real robots. That was a really interesting session.
What was it about?
Yeah.
Yeah, what kind of robots did they have?
They had some, I don't know the name, but there was one which was like
Oh! Humanoid or stuff?
no, just
Like legs?
Just like 3D printed with a Raspberry Pi inside, similar to I think it was
No, this
the
guy.
Casey
Yeah, the
thing, but it was a little bit higher, so it needed to balance itself, and and other things. I didn't listen to everything, but I think you talk about bots, not robots.
Oh, it's interchangeable to me. What's robots? In a way. Anything specific you would like to learn, the audience, since we have the time? I can steer it a little bit. Okay, freestyle.
Enough coffee.
No, I don't have coffee. I'm not sure how I'm gonna handle the towards the end. Let's see. I have to slip myself a little.
I think we can start.
Yeah, I think so. Okay, good morning everybody. As this is our main lecture hall, this is also where we do general announcements. We're not gonna repeat the opening from yesterday, but just some information for those who didn't catch it, or maybe to remind you. Very welcome from my University of Applied Science. I just talk about the value and what's special today. Today, I want to remind you that the library has opened. So if it's in the ground floor, just when coming in to the left of the entrance, it's a 2-floor library, nice to watch. So if you have time in between, just go there. They're prepared to welcome you and maybe show you around a little. Just don't hesitate to ask the person. It's right there. Second announcement today: the open VLAN that should have worked yesterday already indeed works. So if you need VLAN, you don't have to go for a password. You can log into Open Campus VLAN where you don't need credentials, and then you get to a landing page where just put in your email or phone number, you get a PIN, and you're into VLAN. We tried it, but what nobody was trying it, that this service has an exception for Sundays. So it was nobody ever tried that, because nobody ever tried it on Sundays. Nobody would expect it to have an exception for Sundays, so that was why we hassled with VLAN yesterday. Then please be reminded that between 12 and 1 we have our famous cafeteria, which is open the whole day for serving coffee. We also have some automata, but you know the coffee at the cafeteria is quite a lot better. And they're offering sweets and anything, and lunch is served between 12 and 2, but please between 12 and 1 only go there if you have a voucher, if you have prepaid voucher, such that we can serve the masses fast, and if you don't have a voucher, go at the cafeteria at 1 o'clock, please. Yeah, that's about it. I think now welcome to the conference, second day. And we are eager to hear the first talk. Thank you.
Thank you.
So, good morning. The first talk will be about software stack for controlling robots, and Jan Mageta will present it.
Let me turn this on. Good morning. Good morning, everyone. Great to be here with you today. And today, coffee machine is working as a robot. The VLAN was not working yesterday because people. So today we're going to talk about robots, but not the kind of robots you see in the sci-fi movies, more like the real useful robots, something that I got quite excited recently. It's a robot that you can maybe build at home to do your laundry and stuff like that. And by the end of the talk, I do hope that you will at least get inspired a little bit to try some of these techniques maybe at home, and maybe get the robot and start training it. So, who am I? I've been a Pythonista since 2008, and that makes 18 years. I think I've officially became the Python adult, if that can be said. I did my bachelor's in automation, master's in computer vision and robotics, then did a PhD in medical imaging, and then I founded a company called Cardiomy, where we do software for medical image analysis in cardiology, otology, neuropsychology, and many more. But now my current excitement is like, okay, I want to revisit the robotics part of my studies a little bit. And the field has changed so much. It's barely recognizable. So I want to share a bit of that with you. So, bots and physical AI. I've been doing a lot of AI recently over the past years. But the AI usually is just software, like it processes images and it does some output. but does not touch. So actually, let's add a bit of the physics inside, like let's add something that can interact with the world physically. And that's what physical AI is. And there are different types of robots in the world. And I guess the main three categories that you can find are the station robots, like the manipulators in the production lines when you have an automotive factory, placing doors on the cars, and doing very precision, highly repetitive, accurate work. Then you have maybe the locomotion robots, the mobile robots, which, for example, the Mars rover on Mars, or there are submarines inspecting the pipelines underwater. But there are also hybrid specialized systems, which are more experimental, like building those humanoid robots, or even like mobile robot combined with some manipulator, which kind of puts the two together. That is then like, how do the robots interact with the world? Well, they have essentially two main things, two main components. They have sensors and they have actuators. And the actuators are the ones responsible for the gripping, pushing, and pulling, and all the interactions with the world. Sensors tell the robot like something about the world, what they see, and what they perceive, and how the world kind of works, but not really, because then they need to interpret it. So there's also another layer, which is kind of like the decision-making layer of the robot, which senses and then acts based on what it senses. The typical thing that you find in traditional robotics is the concept called degrees of freedom. So degrees of freedom is the number of independent axes of simplified rotation, so that the robot can achieve its position. Most commonly, robots or manipulators have like 6 degrees of rotation, 6 degrees of freedom, which is perfect to achieve pretty much like any XYZ position in space and any orientation in space. So orientation is the roll, like if you have a plane, then you have a pitch. If it goes up and down with the nose, and then you have yaw, which goes like along the third axis. So by knowing X, Y, Z and the 3 angles, the robot can get anywhere. So that's exactly like what you have the robot here. So this is a little robotic arm that has 6 degrees of freedom. So there's one in the base, the robot can rotate. There's one in the shoulder, elbow, and then in the wrist, and also the wrist can rotate, and there's a gripper which can open and close. So this brings us to the concept of the pose of the robot. As I said, there's this X, Y, Z, and the three angles, which let you know like what is the position and orientation of the end effector. And end effector is usually like the tool that's attached to the last bit of the robot, like the gripper or some tool that's maybe specialized to the application where you want to apply your robot to. The second bit is, okay, so you have the position, but you also have the configuration. Like what are the angles of each of those joints? Like typically in an arm like this, you have those 6 angles that describe the full configuration of the robot, which is maybe like from here until here you have something like 180 degrees. This one is maybe a bit more, but essentially the angles is something that you can set to the robot, and the robot, thanks to its internal control loop, will try to achieve those angles. But the thing about how to control this motion and how to get the position where we want to be, so there are these 2 schools of thoughts. And the one that I studied was the traditional robotics, where you model everything explicitly. So you have a mathematical precise model of the robot, you have the geometry, and you learn, not learn actually, you use normal standard algorithms to find a way to get from point A to point B, for example, and so on. But there's this new school of thought where actually not much is that explicit, and things are more learned from data. So let's start with the traditional robotics, and the part 3 will be about the more modern stack. So to model the robot, as I said, you have these concept of joints. So you have links that are like those just fixed, rigid things that connect the joints. And typically, in the traditional robotics, you model them by just a set of transformations. So if you have an arm like this, You know that there's a rotation around the z-axis. Then you have to go up a little bit in space, and you connect those chains of transformations, very much like in computer graphics if you compose a scene. But here, so there are many ways to do that. But in robotics, there are several conventions. One of them is the so-called the Denavid-Hartenberg configuration, where it kind of prescribes you like which direction, which axis you should go first, and so on. And there are tools in Python for that. When I was studying, I think the very best tool we could have was Peter Kork's Python robotics toolbox in MATLAB. Of course, no one here is the biggest fan of MATLAB, I presume. But we have exactly the same port. Peter Kork ported the tool for Python. So that's where you have now the robotics toolbox for Python, which can also work with all the main things that the MATLAB toolbox could. It supports the so-called URDF, Unified Robot Description Format, which tells you exactly what is the configuration, what is the geometry of the robot that was originally coming from the robot operating system ROS. Another tool similar is Placo. So let's see how to get the robot moving. So there's first thing, the forward kinematics. The forward kinematics maps the robot configuration to the robot pose. So you can see that, okay, I know what are the angles that I want. What is the position? So it's actually fairly simple. You just compute the transformations and you achieve some position. And if you use Robot Toolbox, there's this submodule called, well, not here, but there's a submodule that helps you compose transformations. But here, it's just simple. You open the robot, and then you do fkine computation to compute the so-called forward kinematics of the robot, which gives you back the forward pose. And the forward pose is exactly that, the 3D position in space and the orientation. It is represented as a 4x4 matrix because it's easier to work with. But that's all you get. And that's the easy part. However, that's not as useful as knowing, like, I want to achieve point X, Y, Z and orientation Y. I want to maybe grab this bottle of water. Like, how should I approach it? I probably should not hold it from the top, and I should probably just grab it at this place, at this orientation. It doesn't help to go this way, and so on. So you want to be able to compute what should be the joint configuration to achieve that orientation and position. And that's called inverse kinematics. So from the final position, you get the joints. And well, the little issue here is that there is no necessarily a solution because the place is maybe not reachable, and maybe there may be other multiple different ways to achieve that. So even if I move my hand and I fix my wrist, I can probably have different joint angles to achieve the same position. So there are ways to constrain that and to solve it. Of course, robots themselves, like this one has 6 degrees of freedom. Our body has something over 200 degrees of freedom. The hand alone has 27, so we have 25 in the fingers, which makes us pretty dexterous. And you have 2 in the wrist. And so it becomes a bit challenging there. So to solve inverse kinematics and forward inverse with Placo, it's very similar to the robot toolbox. There are 2 functions for that. You set the target position, whether the position of the robot or the angles, and you update the kinematics. Once you know the kinematics, now you can start to plan, okay, how do I get from point A to B? And for that, there's usually the trajectory planning. So you define some point A and maybe some key points along the way you want to reach. Of course, you want to avoid obstacles, so if there is something in the way, you probably need to go around. And that's where your key points are usually planned, and there are algorithms like recursive randomized trees, for example, RT or A-star that actually help you to define those key points and then plan the trajectory. Of course, you want the robot to move smoothly, so you don't want too much jitter. You want nice accelerations, and maybe in the second derivative of the acceleration to be kind of smooth so that you don't destroy the motors. And so there are tools in the robotics toolbox that help you plan the trajectories that are smooth. So with that, then you can start to apply like traditional feedback control. You know where you want to go, you plan the trajectory, and of course you're never going to end up where you want. So you have sensors, and you associate the data just from the sensor with the real position. You try to estimate the position, often with Kalman filters and so on, and you use PID controllers or maybe something more advanced, like a model predictive control, where you estimate a longer horizon of what's going to happen. But in general, you want to close the loop so that your robot follows what you want. And for that, there are multiple sensors in robotics. So like cameras, lidars, ultrasound, and maybe like force or torque sensors inside of the actuators themselves. But the challenges are that there are variations in the real world. So like, if we turn off the light here in the room, the visual scene will look very different today than during the day and during the night. Maybe the bottle shape will be slightly different if I compress it than when you see, and so on. Like there's always variation. But at least in computer vision, the tools have matured quite well since the last 10 years. And you have ready-made tools to do object detection, like RFDTR or YOLO, objects to detect objects, or even to segment and detect objects which you have never seen just by textually describing them. So like you see here, the image was never trained to detect taxis. It was just trained to normal objects. But it was connected with a language model to create a vision language model, VLM. So by language, you could describe, oh, actually, I want to see taxis. Or maybe I want to see the blue taxi, and you can actually just steer the detection in that direction. So this is very, very helpful for robotics. Another thing that's super helpful are the simulators. So in Python especially, I have different simulators. So there are simulators for multiphysics, like the SOFA framework or the PyChrono. And for rigid and soft robotics, you have now emerging the simulators like Isaac Sim, with its friend Le Isaac, which generate a fairly photorealistic GPU-accelerated simulations. And also Mujoko, it was originally used by DeepMind to develop their learning strategies, together with some other libraries that offer more extensions to that. Plus, there is a thing called like soft robotics, which helps you simulate soft robots, as we'll see in a bit. And the PyBullet is mostly a game engine, but it's actually very quick and lightweight.
What is meant by soft robotics?
What is soft robotics?
Yeah, does it mean pressure or what?
I'll have a little demonstration of that. You'll see. Of course, the simulation is never close to the reality perfectly, it never matches. So you might want to randomize the domain a little bit. So if you simulate the visual world, you want to change the texture, the sizes, the lighting conditions, and so on. That kind of makes the world expand a little bit more. And also it helps you maybe to identify the system that you're working with at that moment. So controlling things in Python, yeah, does this work? That'll probably not work. Well, you can imagine that controlling a humanoid robot in Python is actually fairly hard, but it's not anymore. And this thing is that making this thing stable with traditional techniques, with so many degrees of freedom, computed inverse kinematics every 30 frames or so, already controlling inverted pendulum, maybe if you had control systems, to keeping it upright was hard. Making double inverted pendulum is much harder. Keeping that thing upright is crazy hard. And so the question about soft robotics, if you now move one slide further. So soft robotics is the thing that you can actually control robots that are not like rigid. So maybe you can 3D print a mold for your silicon. So you inject your silicon inside your mold, and you use maybe some compressor to put air inside of the mold. And based on the injection of the air, the robot deforms. So for example, here you have those, or here you have those 3 flexible bands that kind of you can control, and you can maybe change the angle of the little maze that's attached to them. So this is kind of like the newer application of robotics, like to explore. And I think it's really cool, but it's extremely difficult to control with traditional robots. So Where traditional robots shine is when you have this exact, precise, repeatable mechanics, where you can predict the behavior, and then they're fantastically reliable. Like on the production line, you want the cadence that's perfect, that always comes the same way. In their controlled environments, they're usually fairly safe, and the failure modes are fairly understandable. But they do fail in those real-world conditions that are not structured. So like you don't want an autonomous car that's like said, okay, if you see a red light, stop. Maybe there are some other conditions that you need to consider as well. And they're also hard to scale to complex perception, to multimodal inputs, and yeah, every new robot, every new task requires a bit of engineering, a new exploration. But so what if we could actually kind of learn these things instead of engineering it like all fully? And that's where the third part of the talk is about learning-based robotics. And the base of learning-based robotics is in data. When I started with computer vision, it was about the time when the whole dataset, the ImageNet, was published. So the ImageNet dataset allowed us to actually make this whole thing of deep learning work in the end. And that's all that's there, that's the base. So we have a base of large-scale visual data. You have all YouTube, you have all the networks that share images, that share videos, that you see on the images the interaction of things with the world. So if I hold the bottle and I lift it up, the information about the physics of holding the bottle and lifting it up is there. So the friction and all the things is there. Then there's the middle layer, which is the simulation part. So you can simulate worlds that you've never seen, that you will never see, but also worlds that are close to your environment. And the final, the cream of the cream is the top, the real world data where you acquire data. They're precise for your application. But they're really scarce, and they're typically fairly expensive to acquire. So that means that the whole robotics stack changes and moves from this like engineered perception, state estimation, planning, control, to something that's more like learn. So all the inputs that come to the robot inside of it, whether it's images, whether it's ultrasound, and so on, there's some encoding, some processing happening, usually a neural network, and that typically extracts some features, and then using that, you also have a robot is more almost like a black box now, which has the observations, and the model outputs the action, like what the robot should do. So that we then move to more like interactions over explicit modeling, and that scales quite nicely the more data you have. So one way to actually learn this thing is with reinforcement learning, and that's usually working fairly well where the simulation is accurate, like maybe some locomotion where you can describe what is the good ideal state, so it means that you can give it a reward. So walking upright means that, okay, I'm usually pointing upwards, I'm not falling, so I can describe that, I can give the robot the reward. And so that's the reward shaping, that's how it's called. It's usually hard sometimes in other applications. Sometimes it's just not easy to do robot shaping. For example, if I have a robot that's folding my t-shirts, what does it mean to have a good folded t-shirt? Or what does it mean to do a nice painting maybe? That's not a real reward. But in general, you want to learn a policy. A policy is a mapping, is a function that maps state to action. So state is all that the robot feels and knows about the world, and action is the output, the motor commands, the prepare commands, and so on. Now the question is how to learn a good one. And as I said, reinforcement learning is fantastic if you can simulate it really well. And that's where, for example, there's this work about simulating tons of grippers, picking up blocks at different positions, and you can simulate that with MJLab, for example. It's based on Mujoko, the library, the simulation library I talked about before. And well, there are plenty of great reinforcement learning tools that implement most of the baselines for reinforcement learning, all the algorithms and all the different gyms, essentially the environments where you can train your robots on. However, what I find kind of more interesting is now the way how we move from repeating what a human can do by so-called imitation learning. So it's as well called learning from demonstrations. So often you might have two robots. One is the leader, one is the follower. And if they're identical, then the joint positions are the same. So if I do movement on one, and the movement on the other one would be repeated. So I can teach the robot to do the task that I want. It does not necessarily just one robot. You can have like 2 arms and so on. So what imitation learning is doing, it takes essentially a sequence of frames and maybe the current position of the robot, current configuration, and it predicts the action sequence, what it should do next. And that's exactly what the ACT algorithm, action chunking with transformers, is doing. So it tries to predict the next chunk of actions the robot should do. And of course, you don't want to predict just one action because then the movement will be jittery. So you predict maybe like 50, 100 actions in the future. And the actions mean like what the robot should do every, if you have a 30 frames per second, every 30th of the second. So 100 actions gives you something like 3 seconds of prediction horizon. This technique is very efficient, even on low power hardware. So you can run it even from a normalish laptop. It uses ResNet 18 as the vision backbone, so it's a fairly common computer vision neural network that is able to comprehend the scene and understand the scene. And where it works really well is where the scene does not change too much, where you can cover with your examples, you can cover the space of variations. So if I would be training this robot on picking something up, I would need to place it on every single position where I expect it to be used, and then the ACT algorithm kind of interpolates between the positions. Another interesting part of that is that there's this latent styled variable built with conditional variational autoencoders, which lets the robot learn like the different ways to achieve the task. So for example, again, like the task of grabbing the bottle, the robot can grab it from here. It's all good. But if it would try to learn at the same time, and there would not be like this latent style variable, which defines the style, like I'm grabbing from the right or from the left, then it would maybe try to interpolate between the two positions and go like straight through it. So if there would be like an obstacle in the middle, it would like try to grab it through the obstacle, and it would not work. Nevertheless, it's a really great intro technique to this less explicit and more implicit learning-based robotic control. Another technique is based on diffusion policies, which understand that there are usually like different ways to achieve tasks, and they try exactly that. They try to learn this multimodal behavior of the world, and in a way, if you've used all those image generation techniques based on stable diffusion, it's a very similar approach here. But instead of trying to, so you start with noise and you denoise the noise so it creates an image. So you iteratively remove the noise and it starts to look more and more like an image. Here you start with noise and you denoise it to become an action set of actions for the robot. And so that's pretty useful if you have those multiple ways to achieve a task, and also if you want to sample those different ways to achieve a task. That, however, brings us to the place where I mentioned the ImageNet also before. So this massive explosions of data sets where you can start now to put everything together. So you can let the robot learn something about the world with the vision language models. You can also use all those human interactions, all the human annotations from that by different robots, and put it all together into the vision language action model. That also lets you to put maybe the prompts of what you want your robot to do. So you can start to tell the robot, okay, pick up the red cube and put it on the blue one. And by encoding this information, the robot starts now to understand, there is a red cube and there's a blue one. And the vision model that's guided by this language knows what to focus on, and actually the robot can then generate actions that are relevant to that without explicitly coding that. And I think some of the main examples is the Pi0 family of models, which are trained on these kind of very large data sets of robotic demonstrations. Compared to the diffusion, they used something that's called flow matching, but it's quite similar to how diffusion works, just it's faster and the trajectories it generates are smoother, and the whole training is more stable. So that's quite the advantage, and it starts to behave usable for this open world generalization. There are new environments that is never seen, so if it comes to this lecture room, it should start to understand what it sees. If it goes next door, it should start to see that as well. And it's also hierarchical. So if you use your language models, there's also this concept of the chain of thought. So if you want to get from point A to point B, you kind of plan the trajectory. So you can, so if I want to go out, there's a step, okay, I need to dress, I need to put my shoes on, I need to unlock the door, and I need to open the door. So these are all different steps, but the task is like get out. So the Pi0 model then is able now to kind of reason about this planning, this middle steps, and see what the next level action should be, and it keeps it grounded, so it means like the robot is always aware of what it should be doing next. So it doesn't lose the context, and it can start working over minutes instead of like seconds or what we had before. And another similar model is GR00T or GROOT from NVIDIA that was published like 2 or 3 days ago. And if you've read the Thinking Fast and Slow from Kahneman, it reminds me a lot of that. So you have two systems. One is this fast system, the actor system 1, which is responsible for the immediate prediction of the next step, like a movement of the robots. And then you have the system 2, which is more like the thinking, the brain, like a long-term planner, which runs at a lower frequency. And the two systems share the information through cross-attention. So that's the beauty of it, so that the system always stays on track. And that helped them to do something like this. So by training the model on a lot of videos, by tuning the model on this application, they were able to train these humanoid hands to do something that's fairly dexterous. And that means if we can start, this new behavior is starting to emerge if we use these large data sets of data. But the large data sets of data, now like, it would be quite scattered around the world and different formats and so on. It would be painful. And there's this new format that has emerged also, the Le Robot dataset, or Le Robot dataset, which is Le Robot is the library. And they made this format that's, I hope it's going to become a standard. Because it handles this kind of robotic data fairly well. So it has these 3 components. There's this tabular, as they call it, section, which contains all the joint positions across time. Then you have the visual thing, like the data streams that you maybe want to encode with your video codecs because it's way more efficient. And then you have the metadata that connected the things and maybe annotate like where things are happening. And that scales quite well. And there are already like thousands of data sets on Hugging Face that are quite applicable. So if that is now a data set that we have large data sets. So we can start to think about what would be the learning-based milestones for these techniques. So the first one would be maybe the data efficiency. So maybe we can train a robot that does the task with 10,000 demonstrations. But maybe can we get to 1,000, 50, 5, 0? Can we do that? Maybe that's how we can measure the progress of this field. So that's from the large data sets to the zero-shot robotics, and finally the cross-embodiment. Like if I train my robot to, if it's like an arm like this, if I train it to grab a bottle, maybe I should be able to transfer that knowledge to a humanoid hand that can also grab the bottle because it learned something about the world. So let's maybe try and to build a robot, and let me show you how this thing can be done. So we have this Le Robot library, which is this Python toolkit for real-world robotics. And it already, as we said, it had these data sets, so it has this standardized data set format. It has also in the policies, the ACT and the GROOT and Pi0 and more, that you can then apply it to you can try, and they're fairly modular, so interchangeable. There is all the things about hardware control, so you don't need to implement anything about the servos, for example, if you have the standard ones implemented, but it's quite simple to extend the library. And there are plenty of tools to record the data, train the data, evaluate the data, or calibrate the robot, and so on. It is also a good set of visualization tools. So this is the SO101 robotic teleoperating pair. So this is the leader. So I have not touched this one yet. So this is the one that gives the demonstrations. So you have essentially the same configuration as the main robot, just slightly less rigid, so it's easier to move. But instead of the gripper, you have this little attachment which it fits better in human hands. So, and you can control the gripper by this thingy. So the leader controls the follower. The follower follows the leader, of course. And it follows it one to one. And so we have 6 servos. The base is like the main rotation. There's this shoulder, elbow, and the wrist, and then the wrist roll and the gripper in the end to open and close the gripper. To define a new robot is actually quite straightforward. There are like four different classes that you need to define. One is to define like what are the observation features, like what does the robot see, essentially the servo positions, for example. One is the action feature. So this is like what the robot can do as actions. Then there's like to get the observation. So like once the robot is in the world, you want to maybe measure something. You want to get the position of the servos, so it just returns you that. And you also have the send command function, which lets you send a command to the robot to get to some configuration that you want. Okay, but of course the robot is not a library that's used quite a lot for nothing. You have all these two robots are already there and many more. So you don't have to define them anymore. All you have to do is to figure out like to which port of your computer are they connected. So they're communicating through a serial port or via USB. So you need to tell which interface it is. Once you connect them, you need to calibrate them, but that's what it does for you. So all you need to do is to put the robot in kind of like the medium position and then find all the ranges of motions of all the joints. So you kind of put it to all extremes possible. And once you have that, you can start now to set up the robot to do chores in your household. So you need to connect the 2 robots. I've already connected one. Let's connect the second one. You need to calibrate, as I said, find the ranges of motion. You need maybe something like, something for your environment. So maybe some kind of like a container and maybe something like your sock. I think this is the first time my sock will ever be on the desk of a Python conference. And last. So then you can start collecting the data with teleoperation. You can run the Python tools, like the script is fairly simple. What it does is just reads the information from the leader and sends the configuration of the joints to the follower. But also you can use the command line tools from the robot library. You tell it which one is the leader, which one is the follower, and if you have a camera attached, then you also tell it like which camera it should be using. You can have multiple cameras, so it's quite nice. I was using only one camera that was mounted looking at the desk, but there is also a little attachment for the camera that's looking more at the gripper, which would make everything a little bit better. And there can be more inputs than just 2 cameras. And so this is how it would look like, but I guess we can see that in practice. So the leader tells the follower what to do. And then once you collect enough data, so I can put the sock into 50 different positions on my desk, and I can try to can control my follower to get to solve the problem 50 different times. I can see that in the Hugging Face interface, you can quite well visualize the data sets, but also you can visualize that with rerun. And rerun is this beautiful library that lets you stream in multimodal data. So if you see, it's kind of like logging, but for visual data, so or scalars or so on. So by simple like rerun.log, you can store like this temporal data that's then well synchronized in time, and maybe we'll get to that too. And finally, we can train the policy. So here I train the ACT policy, which is the one that's quick. So that's the advantage. You can run it on a fairly low power hardware. So I ran it on my GPU in 30 minutes for 20,000 iterations on those 50 demonstrations, and was already starting to produce something. Of course, I could monitor the whole training and see when the thing starts to converge and when the loss drops and stabilizes. So that the training loop actually is not very different from all the other training algorithms with Torch. So essentially you iterate over a data set and you get the new data sample and you predict the next policy and you compare the policy with the desired one. And you compute the loss, back propagate, and then once you are happy, you stop. Deploying it for the robot to run is also, there's a command line tool. You replace the teleoperation function for the policy. So the policy now takes over the teleoperation. And so the inference loop is also like very simple. So you get the observation, you get the measurements, you maybe pre-process them if needed. You select the next action, gives you the new policy. Then you maybe post-process the policy, which means like, okay, I restrict my arm limits to something that would break the robot. And I send the action to do the task. And voila, the trained policy in action is grabbing that sock from my desk and putting it into the container that I set next to my laptop. The slightly tricky thing with these things is there are too many cables and there's never enough space on the desk. So as you see, here I have the chance to be more spread apart, which is really good. And that's a simple robot. Of course, it's not doing my laundry yet. If you want to do the laundry, then you need to do a bit more of data collection. And there's a really good tutorial by the Hugging Face folks about folding T-shirts, where they apply the Pi05 policy. Collecting a lot of data and also using this kind of thing called real-time chunking, so the movement is not jittery, so you kind of interleave the prediction and the movement and so on. And in the end, they managed to fold the T-shirts. It did require quite a significant number of demonstrations, and the success rate is still not 100%, but I guess we are going to get there. So in summary, if we could wrap this whole thing up in some way, I think we're kind of experiencing this almost like a Cambrian explosion of robotics, where we have now millions of hours of data, including the real physical interaction. We have simulators that are really good to simulate infinite possibilities, infinite scenarios. We have these new training paradigms like the vision language action models and imitation learning that lets you train your robots. We have a new data set, hopefully standard, that I do believe that's going to become something like NumPy array, standardized interfaces in data science. And we start to have fairly affordable robots that you can buy and play with at home. And so, of course, there is still a way to go, but robots are already changing the world. And you start to see first self-driving cars in Netherlands. You start to see first marathon robots winning against humans. But we are still far. There are still many failure scenarios. And those will take a bit of time to solve, but we'll get there with these new tools. And if I could now try to turn my robot on. So if I... Is this? Yeah, there's a follow sh command that I made that was exactly the teleoperation thing. So let's see if things break or work. It's all connected. Or maybe we can do it after the talk. With that, I hope that this inspired a little bit to play with robots, and thank you very much for any questions that you might have.
So thank you very much for your talk. I guess there will be some questions. So, who wants to? Just a moment.
Use the microphone, or is it like can I also talk without the microphone? Thank you for your talk. It was really nice.
Thank you.
One thing that I want to add for anyone that's interested into grasping specifically, like there's this company called Ambidextrous, and they have like multiple data sets. One of them is DexNet. Maybe you already know about it, but for example, like if you have 3D data, 3D meshes of the things that you want to grasp, then you can use DexNet, and it has like a probabilistic generator basically to generate different grasping poses that you can then feed to training. It's also really interesting. One thing that I wanted to ask about, like I haven't used this ACT before. Is there like, what is kind of the policy horizon that you're talking about here? Is it like a second or less than a second? Is that configurable?
Yeah, it's configurable. I use 100 chunks, which means 100 divided by 30 is like 3.33 seconds horizon.
Okay, yeah, because something that I noticed, not in your demo, but in the GitHub, there's like a video of how exactly these robots move, and they always jitter, and also in the NVIDIA demo.
Up maybe. Yeah, it's alive. So yeah, that's how they move. I don't have the policy to turn on. I don't have the camera, but at least the follower and the leader follower. I think it just got excited by knowing that there are more robots in here. So now we can like grab the stock and put it somewhere. And that's how you train it. Like you train those 50 or so demonstrations, it starts to do something interesting.
Yeah. So for example, like in the GitHub, there was a video where two of these arms pass something around, I think, and when the arm is waiting, it's jittering like that. And I think is that maybe like an artifact of the model always generating like motion primitives, and so it never really knows how to stand still, I guess, or. It hasn't learned that with like a small amount of data, I think.
That's possible. Even like a human walking is like a controlled falling, right?
Yeah.
Like we keep like always balancing. So yeah, the robot also the 30 frames per second maybe to control is maybe not enough.
Yeah.
It's possible. Yeah. Maybe it overshoots sometimes too.
Because it's also what it like in the Groot demo with the robot where it handled those. I'm actually not even sure what the English word is right now, but. Like the syringe, right? Where it handled the syringe and it was always jittering like that. Even though it did its motion like in general, it was still pretty noisy.
That said, the thing was the video was sped up like 8 times or so.
Okay.
I think there's so like the little thing like it's
reason.
probably slow enough. I could not run the Groot thing yet, but I presume it's because of that as well. Like it enhances the jitterish behavior a little.
And for running like your already trained policy, what is the compute that you need for this small thing? Like, can it run on a CPU or with like can you run it on normal RAM, or do you need a GPU in order to do it feasible?
So to train it, it used something like 7 or 8 gigs of VRAM on my GPU. To train it I trained it for like 30 minutes on RTX 3090. It's totally feasible to run it on a CPU, but you might expect a bit more of the jitter. Because it predicts and it has to wait, then it predicts and so on.
Okay. Yeah,
but it's doable.
Okay. Thanks.
Thank you.
So, some more questions? So if there are no more questions, thank you very
There's
much.
this one, there was one.
Hello. How much is one of the hands?
So both are like 250 euros. So one is
Okay.
like 125. In the end, you can 3D print the skeleton.
That's
You
what I
can-
wanted to talk about.
It's
or
fully
ask.
open source, so actually they have whole STL files. You can 3D print them. So if you don't have to buy those arms, you have to buy the servos. Yeah, there's 6 servos. One servo is like 10, 15 euros maybe. So
Are you also building your own?
to build my own.
Yeah. Do
Possibly.
you try or do you aim to?
I tried. My 3D printer is not precise enough. It's not because this requires any particular precision in printing, but it just leaks a bit too much of the plastic and the servos could not fit in. But
Yeah, okay.
it's tunable. I did not have the time, and in the end, it was more comfortable to do.
And do you have any other robot types, let's say, except apart from the hand?
That's the only one for now. But
All right.
I will certainly be playing with the end effector to have more than just a gripper, and let's see
Right.
where it goes.
Thank you for the answer. Thank you for the talk.
Thank you.
So, some more questions? So, then thank you very much for this interesting demonstration.
Thank you.
So to go to some other presentations.
Ich frage mal, was
Ja,
los ist.
ja. Das nächste ist die Bauung und Breiten.
Isn't that academic 15 minutes?
Yeah. Could I just make a photo of the box? The box? Yeah, because it's... Next is the body lighting. Yeah. Ja. Die Bugsmarter, ja. Okay. Ich bleibe eh da, dass der Laptop nicht verschwindet. Ja.
Ja, manchmal.
Ja. Ja. Okay, gut, bis später.
Bis später. Ich bin vorne am Schalter.
Ja, gut. Just wait 2 minutes. So, hello everybody, welcome to our next talk, which will be given by Mrs. Cheng Ho about how to efficiently debug Python.
Okay, hello, good morning. And yeah, good news, I arrived. And bad news, I'm not wearing my kimono, which I was wearing yesterday, because, time is, very essential because I wake up late. That's why I decided to go simple today. So, debugging, and I want you to be very honest with me when you ask you a few questions when we start talking about debugging. So, first of all, can you give me a show of hand, how do you debug? So, if you can choose multiple, if you have done it, you have used, or you are still using it, then, put up your hand. So first of all, you use PDB to debug. Okay, good. 2, you use a debugging tool in your IDE. Okay, good, wow, okay. 3, print. Okay, I love your honesty, yes. We have all done it, right? Like, it's just a script, I just quickly print it and see what's going on. There's no shame in that. I sometimes do that as well, but there's other way, which, when print is not working, then we have other options, right? So, first of all, why do you use print? Well, I have, maybe give you an example. Sometimes you just want it quick. And I think it's when I am teaching Python to beginner, this is, a no-brainer because you're already teaching them very simple things in Python. I think it's the easiest way if you just, you're teaching them hello world and then print hello world, and may as well teach them to print something to inspect what they have created in their Python code instead of introducing a new tool to them that they would get super confused. So that's good, I think everybody can do print. I think, probably that's your first Python statement you write in your life. Another way is that, again, like, I just want to have a quick peek of my silly little script, that whether that works or not. So, again, I don't have to import anything. I don't have to open it in a particular IDE to use the tool. So I just, print is there. It's built in. It's with your Python. So just print it. Yeah, so that's straightforward. That's no-brainer. That's simple and beautiful, right? However, print is not a elixir that can solve all your debugging problems. First of all, have you ever done this before, right? Like you have, tried to work on a relatively sized code base. You have have some prints here and there and try to have a peek of what's going on here and there. And then when you think you're done, right, maybe you try to commit and push back to GitHub. But then you have this linter that you set up with your pre-commit hook. And then once you try to commit, you see the error coming in because the linter say, you have a print hanging here. Are you sure you want this print, right? So yes, knocking, yes. So so a lot of linters. So for example, if you use Flake Age or use Black or Rough to check the format, probably you would see this happen, right? Because, well, the linter expect that this is a print that you forgot to delete after you try to debug. So linter doesn't like it. Another thing is that when you have, I have this a lot, right? Like I do data science things and sometimes, involve going through all the data one by one, so it has a loop to loop through everything. If I try to print every single time in a loop, it's a huge mess. It's like, you see all the prints, all the things just come up, and then you can't go, hey, I loop it 1,000 times, and you have 1,000 lines of code, 1,000 lines of print out that you're like, I can't really see what's going on. I wish after printing, the program will pause there, so I can actually have a deeper look and have a thought of what's going on, right? So print doesn't give you that. Print just prints something and it moves on. So can't do this. So yeah, if your program is huge, if you are like calling this function, calling that function, calling this function, and then a lot of things kind of intertwine with each other, or if it's even worse, right, you have async program. So again, which part of the program I'm in right now, you just print it out. You don't actually know where is it. And especially if you have multiple prints, right? So it's like, it's it's not the best way to see what's going on. So yeah, print is limited. It's not working all the time. So when print is not working for you, maybe you have to think about using something else. Yeah, I already mentioned some of them. It's horrible, when you have a very, nested, design of your code and concurrency and race conditions. So again, like async code, right? Which print does this come from? Is it from this thread or that thread or this, coroutine or that coroutine? No idea. High frequency loop is the 1,000 lines of print that I was talking about. It's like, oh, too fast. Pause. I can't see. I know when you train your model, again, you have multiple loop, you have to do it again and again, and that's why we have some other tools that just, show the progress instead of just print out first loop, second loop, you go crazy. Complex data structure. Another downside of print is that sometimes, because print is just a line, right? You can't inspect different parts. Let's say you have a dictionary, right? You want to look at the inside of different part of the dictionary or different attribute within an object, then print is not good because you have to put all of them even though you don't know whether it's relevant at that time, before you run the code, you have to print all of them out, and they are maybe, and also dictionary, sometimes, it's very hard to see. You can use pre-print, but still, what if it's super nested, right? It's not going to help. And sometimes environment-specific issues, you won't see it until it's runtime. If you just run and then if you print, and if it's not at the specific environments, for example, you're running in a Docker container, and unless you are in that Docker shell, you can't actually see, right? It's just print out at the standard out. So it doesn't help. Okay, alternative. So yay, we have all these good things to help us. Use a debugger. So this is basically again, well, we are debugging. So the tool for debugging is called debugger. That's very straightforward. And also, if you say that I'm using this debugger, I'm using that debugger, you sound like a pro, right? Not just print, you're a pro, so that's good. So the first step, migrating from print to a debugger is to use some very simple standalone debugger. So you don't need any fancy setup or IDE to do it. So for example, PDB, I already kind of mentioned it in the first slide. So PDB is in your standard library. So you have to import it, but it comes with your Python, right? You don't have to pip install it. And so that's the original. It has been there since, I don't know, I haven't looked into it. Is it there since the birth of Python? I didn't check, but it's been there for a long time. And yeah, so that's very simple. You just do, like I showed you in the first slide, just import PDB and PDB set trace. That's the simplest way to create a breakpoint in your program. So a lot of IDE actually try to help you autocomplete. If you type import PDB and then the set trace will pop up as a suggestion. So that's one way to do it. Very simple. You don't need anything. It will come with your Python. However, if you're using IPython, which is a slightly better, more colorful, what's it called? A repo of Python, then you can use IPDB. So, IPython, IPDB. So that's the thing. So the community also created a new thing called PDB++. So, PDB with new feature. That's kind of the naming conversion there. So if you found that PDB is not quite enough, but I still want it lightweight and just want something a little bit extra sprinkle on top, then yeah, look into PDB++. Another one that is popular and in use very well together with Django is PyDebug, because it's a set of decorators. So if you are working with a project like Django project that you have, like the standard structure and all these like different kind of things that you set up, then PyDebug will be good, and also it will respect your setting in Django as well. So, it's just throwing a few names. So when you kind of come to a point that you're thinking about using a debugger for the first time, these are the recommendations. But why, right? Why? What was extra that I got from this debugger instead of print? Well, one of the most important things is setting a breakpoint. So what is a breakpoint? Breakpoint is that when you, for example, you are using PDB, when you do the set trace, you're setting the breakpoint there. So when you run your Python script, and then when it hit the PDB set trace, it will just stop there. So, and then it will give you a interface to inspect what's going on there. So not just it pause, it will also let you do some inspection at the breakpoint. So I feel kind of very useful thing is to look into what are the variables value at the moment. If you're incrementing something, maybe you want to check the value, or if you are having some like if statement, true or false, or this, like you can double check. And another very useful thing of doing the inspection at the breakpoint instead of printing it out is that you can decide what to look at after inspecting one thing. So for example, right, you're looking at this dictionary, and then one of the thing inside this dictionary looks a bit weird, and you want to have a deeper look at it, right? So maybe a list within a dictionary is a bit weird. You want to check if the length is correct, and then you can do that at the breakpoint instead of printing. You have to know in advance what you need to check. So that's one of the good things. Another thing is that, for example, if you are at a segment of your code that things are getting super weird, and you want to have a look of it step by step, just like run each line and then pause after each line, you have the option to do that as well. So you can advance your program one step at a time. So for each step, you can inspect closely what's actually going on within your program. Another thing is that so not just you are stopping at the breakpoint, you can also have a look at, okay, what part is it right now? What's the next line of code? What's the previous line of code? So you can also have a look at that. So these are all the very nice things that you could have that Prince doesn't give you if you use a debugger. So those are the command line tools that you can use. Very lightweight, very simple. Some people love it. However, a lot of us, we love working with an IDE because, well, everything is just in one place. You can have a overview of everything in just one window, right? So that's what an IDE can provide to you that a command line may not have. So, so if you're working with an IDE, the chances are the IDE will have some debugging capability that is inside, right? Because that's one of the most important thing a developer do is to, debug your code. So one of the most popular open source projects that is actually designed for an IDE is DebugPy. So yeah, we have PyDebug and then DebugPy. It's like, we are not very imaginative coming to naming, right? However, so why do I say that this is designed for an IDE, right? Because it is actually having an implementation of a protocol that is, available to be controlled by an IDE. So, and also that's specifically designed for Python because, actually a debugger is very, very interesting thing because I've talked with my colleague who works on debugger and then they said like, oh, you have to wrap up the interpreter of Python and then, so you can have all these like extra control you have when you're executing your Python code. So it's like super sophisticated. However, since DebugPy offer all these like protocols, so you can easily, plug it into different IDEs that actually build using those protocols, right? Also, DebugPy have another very nice feature is to do remote debugging. So local debugging, we all know, right? Like, like the PDB, you run it and then you just stop, you run it locally. But some people, they may need the remote debugging because they may be running their code in a Docker container somewhere in the cloud compute, and so they don't have the standard out to look at what's going on. So a debugger that can allow you to maybe see what's going on in your IDE, but then your code is actually running in that Docker container somewhere else, then would be very useful. So DebugPy also provide a lot of very essential debugging feature that other debugger offer. So breakpoint management, you can put actually multiple breakpoint in your code. Again, very standard step-by-step code execution. You can also advance, step-by-step. Usually, it will stop before the when you set a breakpoint at a certain line of code, right? When you run it in a debug mode, you will stop before that line, and then you can execute that line and then see what changes, right? So again, like step by step, and then you can do it multiple times as well. Inspect your variable. I will show you later with an IDE, you can look at multiple variable at the same time, which is again like super useful. Expression evaluation, you want to like quickly check something, you can also do that, whether that works, and then if it works, maybe you don't have to stop your program and run again and try again, that's quite good. Yeah, IDE integration, I've talked about that, is, that's what makes DebugPy stand out. Remote debugging, again, very useful if you're having a remote development environment. DebugPy is actually, I haven't told you this, but I'm telling you now that DebugPy is actually developed and maintained by Microsoft. And of course, it works in VS Code. However, recently, PyCharm also adapted, and DebugPy is also used in PyCharm. So the experience, the user between the two IDE, and maybe they would have very similar debugging experience because, we are both using DebugPy. And so I'm going to show you how it works in PyCharm. Unfortunately, I don't have VS Code in my computer, so I'm going to show you how it looks in PyCharm. But if you use VS Code, you can also have the similar experience as well. So let's look at PyCharm here. Just a very quick demo. Is it big enough? Yes? Okay, good. I will give you 5 seconds to look at this code. There is a logical bug in here. I hope it's not too obvious, because if it's obvious, then you probably don't need a debugger. It's very simple program, right? Probably a student is doing this as a homework, right? So count the number of vowels in a string and then print it out afterward. So hello world, we should expect the number to be 3 because we have E, we have an O in hello, and an O in the world. Okay, so let's run the program. Yay, so it should work, right? It works, but the answer is incorrect. It's H instead of 3. What's going on here? So well, if you spot it, don't show it, don't spoil it for others, because I hope it's subtle enough. But if you're smart, you can find it. It must have been the count, right? It's not 3 at the end, it's H. What's going on? So I set a breakpoint here by just clicking on the line number. You can set multiple ones, but again, like in this simple example, we just need 1 for now. So let's close this. So instead of just pressing the run, in PyCharm, you have this little bug icon. You can just press it, and it will run in a debug mode. So PyCharm actually uses another one, the PyDevD. That is the old one, so that is still the default because debug.py is, it's new thing, it's beta. So you can actually switch between the two. I'm showing debug.py today, so that's why I'm choosing debug.py. And then, I have to make it bigger now. Okay, so in debug.py, you see that the debug window here, you would have, you can see all the variables in one glance. So like instead of, PDB, you have to type, what is character, what is count. You can just see all of them. You can also see like which part of the program is actually being run right now. All these are very low level hidden things that's going on. Most of the time, you don't need to care about it. Unless you have multiple threads and multiple processes and all these crazy things, then maybe you look at it. But right now, don't worry too much about it. So look at the characters, right? So okay, H. Okay, it's a bit weird, right? Wait. Okay, the count. So I'm going to increase counts by 1 very soon. I'm not having count as 1 yet because now the program stopped before this line being executed, right? So now we are having count as 0. However, I don't think we should be hitting this line with the character H. Okay, let's see what's going on. Let's click this, which step over means that I'm going to execute this line of code. So I press it. So okay, it count increased by 1. So now we have 1. And okay, let's continue, right? So because we have a loop, so we can resume the program and then let's see what happened, when it stopped again. So let's click it. So the for loop keep going, and now we are hitting the character L. So we are here, we have the counts again. I haven't increment yet. If I step again, it will increment. So anybody know what's going on? Yes, the logic is inverted. Yes, this is wrong, right? So this is a beginner mistake, Okay, this student made this mistake. They use a debugger, now they can find it, now it's more obvious. So how about I remove it, all right? So we have fixed it, so let's try again. So we can press rerun. So it's just one button, you can rerun the whole thing. So it will start over again this time. When we hit this line, we have E. So, okay, it seems working. So, okay, does it increase by 1? It's increased by 1, so what about next time? The O, okay. What about next time? Is again the second O, because now we have 2, and then, okay. We finished, and the answer is 3, and it's correct. Yay, 100 points for this exam of this, maybe a high school student, I don't know. Okay, cool. So, well done. Do I have time for demo 2? Okay, I also have time for demo 2. Let's have a look at demo 2. Okay, demo 2 is, I hope it's more subtle if you are not familiar with how the OS path standard library work. But if you're familiar with it, you'll be like, I have made the mistake before, silly you. It's like, yeah, I'm silly. That's why I need a debugger. Okay, so what this program trying to do, again, very simple, is just trying to join 3, path together. So we have a base, which is, probably where your project sits. And then if you have a folder in your project, you will have, a folder and then a file, right? So I want to join all of them together. So I know, oh, there's an os path.join that can do that. So, okay, let's close this one first and then run it. And then, ta-da, what do I get? Oh, wait, it's weird, right? I think it's supposed to be user, student, and then homework and a solution, but why I only got homework and solution? Okay, if you know the answer, don't shout, again, no spoilers. So I'm that silly student, so I'm gonna do it now. So, okay, this is weird. Probably this function is a bit weird. So what I can do is to, maybe before I return, I should actually check what's going on, right? So, okay, here. And actually this one, I think the debugger doesn't help too much, but let's see. Okay, and then I can do this. Oh, well, AI is trying to help me, but, okay, silence AI. Okay, let's do this, and then I can now, before I return, I can check, right? So probably this one is wrong, right? So I can, debug it, and then, yeah, what do I have? Yeah, this seems correct, but the result is wrong. What's going on here? So another thing, I think I have switched it off, but no. Yeah, you can also execute expressions. So, for example, let's see if I can do this again and then execute that separately. Oh, okay. This is, okay, so I'm just showing you can execute the expression. So maybe now you can do the os.path and then dot join, right? And then, okay, why is this so weird? Yes, thank you so much. And then join maybe, oh, can I just join the subdirectory and then, I have, and then the file name, right? Does it work like this? Oh, unsupported. Oh, because I need the base URL. Oh. I am so bad at typing, okay. And then maybe I have to have can I have empty for the base URL and evaluate? Okay, let's do this. So what about if I have an empty this, and then I have the base URL? So you can try different things, right? This is a student doesn't know what's going on and trying this. It kind of works. So maybe now it clicks, right? Like, oh, okay, if it's nothing, it works. If it's /homework, it doesn't work. What about temp, the MP, what does it give, right? Oh, temp work. Oh, maybe I can't have a slash because, right? This is what happened, right? So if you have a slash in the folder directory, ospath.join will think that this is the root, so it will just remove the base directory because it doesn't make sense if you have two root. So, so after a few experiments, then this student kind of get it. So let's fix it. So let's fix this by removing this, and then this will still work, even though, not as elegant, but okay, fine. Let's run it, see if it works. Oh, stop and run, try it again. And yes, it works now. Woohoo, 10 points for this student. Okay, that's the fun that we are having. So, cool. Let's go back here because we haven't finished talking about debugging, because another thing that is quite important in the debug world is logging. This is quite useful for logging because if you are, so my partner, by the way, my partner works in observability, so for him this is super important because you want to check whether, when you have a software that is probably running, and if it's like, for example, if you have some API kind of thing, it's running, non-stop on the cloud, it's provider service, you may want to log what's going on so you can have a monitoring of the program all the time, right? So, and with logging, you can, see what's going on. If like a user tell you that, well, suddenly I got this error, it doesn't make sense, then you can see, okay, what actually happened within the program when weird things come out. So usually, what you want in your log will be some initial states, some variable values, again, like the counts that we are monitoring, right? Like if we run it forever, we want to always have a look at that. And execution flow, what function is it hitting, what is triggered, what is running, right? So we need that. So that would actually help to identify, if you're testing it, so these are like QA engineer or testers, like if they hit a issue, or if they are like testing the boundary, right? They're doing some pressure test. You will see whether what's actually going on in your program in a very not exactly import, but in a similar environment with the prod. And also security instance, you can, again, like set it up, not exactly import, but in like, testing setup, which is very similar to prod, and then you can ask your engineer to like attack it, see how much, we are vulnerable, and, maybe fix it before someone actually hack it, right? So. Example, so again, logging is most useful when you have a long-running program that is there, living there for a long time. So for example being, like, for example, you have a website, Django, you have Django website, probably your Django website will be, running. It's not like a script that you finish. API service, that's very similar thing. Security investigation, so if you have those kind of services, you want to check that your security is good. Antivirus software issues, again, like, you want to monitor whether there are some like maybe weird performance issue, maybe something suspicious is going on, then you can investigate. Again, why not print, right? I can always print out, what's the value of this, what is going on, but it print, again, like, it's okay, but it's not enough. So another thing that logging can do, so by the way, logging is a standard library, so you can, again, like use it with Python. So what logging can do and print can't do is that you can set very elegantly in your program the severity level. So because, for example, when you have a code, you can say that, log it, but you can also set a severity of that. So let's say you only want to see the most severe bug, then those minor things won't be showing up, so it won't create too much noise for you. So instead of printing out everything, you can say like, this is major, this is minor, this is critical, then you can decide like in a different run that like what level you want to see, and help you to, filter out the noises. Runtime control. So this is, again, like print can't do this. Like it's at runtime, you can't, do many things because print is just print. It's just on the IDE. You can't even put it in a file, and So also automatic metadata. So for example, if you use logging, the format usually will consist of the time and maybe probably what thread is running or what port it is running. So those things print, you can technically do that, but you have to do a lot of setup for that to work. Multiple output option, again, like print only put it on standard out, and a lot of time is not the ideal place to see what's going on, right? You may want to put it in a file for inspection, or maybe you want to hook it up with another service so you can inspect it on another, terminal or things like that. Persistence, again, like if you can't put it in a file, it won't be safe. If it's gone, it's gone. So this is how a logging can look like. If you have never done it before, if you're trying it for the first time, this is probably what you would try to do. Again, like logging is a standard library, so it's just there. You can just import it without pip installing it. So logging, there will be usually you will see this like configuration at the very beginning of your code, because you want to set like, okay, what level I want to see things. So info is probably like everything. It could be a bug, it could not be a bug, it could just be some useful information. You can also set the format, which is like what time does it hit that point? If you have a long-running program, the time could be very important because you can, kind of investigate when you have, made a request at this time, so you can know that, okay, this is probably from that request. Level, name, and messages, so you can also set those. Format, so you have all the metadata as well. So what information you want to print out, so, or if you want to give an error message, you can also give an error message. This is very, very simplified version of everything. It's only touching the really bare surface. If you want to look deeper into it, please refer to the documentation link over there. Sorry, I think it's not very clear. Talk to me if you are struggling to find it, but it should be quite simple. It's just an official documentation of logging in CPython. So I think that's closer to the end. So again, if you are falling asleep and it's I don't know what you're talking about, don't worry, just remember these 3 things. 1, stop using print for everything. It's okay, no shame using it, but maybe try using something else. Then that give you more features and options. And a lot of tools available for debugging. I would suggest looking into it. I suggest DebugPy, but you can find whatever works for you. Last thing, use the right tool to do the right job. No matter it's debugging or logging, please use the right tool, and then your colleague will love you for that. So I think that's it. So again, I have a little survey. I want you to fill it out. If you don't mind letting me know, how you use AI and all these things, because now everybody's using AI. And my contact information there. And I also work for PyCharm. So if you have any questions or complaints or anything about PyCharm or DebugPy in PyCharm, so then please talk to me. I would be happy to chat. Thank you.
So thank you very much.
Yes.
Is there a debugger in the Python world where you can change a program in the debugger and evaluate the new code without restarting the whole program? Like it's possible in Lisp since the 70s, and there was a space mission where it was very useful. And if you have a complicated program with a lot of state, you lose the state if you restart the program. So I miss this feature a lot, but I didn't find it in Python.
Yeah, I think that's a valid use case, and I think I have just when you were mentioning that, I was thinking, oh, that's why people use Jupyter Notebook, because Jupyter Notebook you execute cell by cell. So a lot of data scientists actually take advantage of that, because in the first cell, it works. They may be injecting the data. They don't necessarily want to run it again and again for the experiment, right? The experiment part, which is the next cell, they could try it again and again by changing the parameters and things. So, so maybe Jupyter Notebook is, the solution for this use case. And I know, this is, again, data scientists have similar issues, because some of the cells take a long time to run because, they're handling a lot of data, but then they have to rerun the experiment. So, yeah, breaking it into different cells and run them one by one, and I think that could be a possible way. For debugger, I haven't tried that myself because also there's a debugger in Jupyter as well, so you can also debug in Jupyter, but cell by cell. But for this DebugPy, I haven't tried doing that, because if I have to do something that you just mentioned, I would probably do it in a Jupyter Notebook. So, yeah, haven't tried that.
Maybe a remark from my experience: if the function you want to change is not in the call stack, you can sort of put the function definition into the debugger. Yeah. Yeah. Another question?
No. Sorry, you have a lot of exercise today.
Thank you. Thank you. Is there a way to kind of connect the debug py with my AI agent so that the AI agent can kind of debug the code itself while it's running?
Yeah, we're talking about AI agent. DebugPy used this. I've shown you before, right? The adapter protocol. So if your agent can work with that, then maybe. However, usually what happens is that, so for example, right, you have DebugPy in your IDE and also an agent in your IDE, so they just kind of have a IDE just connect them all together. So yeah, I mean, I haven't tried it. I guess, you can try that. And yeah, but, oh, by the way, as PyCharm also starting to develop this feature, you can put an agent together working with PyCharm. So, I think, yeah, if you have an IDE that you can glue them together, then maybe it will work. And it's, yeah.
Cool, thank you.
Yeah.
Another question? So if there are no further questions, thank you very much for your talk.
Thank you.
very sorry to announce that our proposed speaker did not appear. So please don't blame me, which we also find this completely very unpolite without any prior notification not to come. But still this is effect. However, in the parallel session, this session is going on, and I asked the speaker time, I forgot his full name, to wait a little, so if you go over there, you will be in time, and they will start before you appear there. I'm very sorry about the circumstances.
Thank you. Thank you.
I think I was just waiting for some people to show up, or like if this.
Of course. Do you want the walk around mic?
No, I think we'll stay here. I think. Is it on?
Try it now. Oh yeah. Perfect. That's good. Are y'all ready? Everybody have coffee? Wake up a little bit after lunch? Right? That immediate after lunch is always the rough one to stay awake for. But now we're all good. We're all caffeinated. I see you caffeinating. I appreciate that. We're all awake. We're all ready, right? How do we feel about sponsors? Yeah, right? Yeah, did you guys check out Sentry? That's good stuff, right? Did you meet Fabian? Fabian's great, right? Let's give Fabian a big round of applause.
So, hello. First and foremost, the most important part, you still have time to sign up for the raffle. You should. There's 2 sets of Lego to win. I will be drawing the raffle like in an hour, like at the start of the lightning talk session. So if you still want to participate in that, come to our booth, scan the QR code, and enter your details, and you can have a chance to win some Lego. Yeah, otherwise, let's get into it. Agents, what do they do? No, really, what do they do? We don't have an idea. We try to have an idea. So first, about me, I'm Fabian. I work at Sentry, and like what has been on my mind for the past year or so is basically agents and how do we actually make sense of what they're doing. First, I'd like to ask a question. So who of you has been using AI in their applications or agents in their applications? Are there anyone? Okay, I see 1, 2, maybe 10, 12, 15. Oh, okay, wow, nice. That's good to hear, because you're potential customers. No, like also potentially sharing the pain that we have experienced. Story time. So when we started with agent monitoring, we basically had a leeway of a week. We were given like time to do whatever we want. It just has to do with agents, so that we can like feel it out. It was still burgeoning, it was a new technology, and we didn't really know how to approach this, what's actually there to be monitored, what could be the pain points and so on. And everything that you see here in the next slide is hyperbolic, of course, but it's still like experiences that we as a team made and we as Sentry made, so that we can better figure out on how to actually make sense of what agents are doing. I'm using like a hypothetical restaurant chain called Bits and Bytes to showcase what we have experienced. So meet Todd. Todd is responsible for the IT of this small restaurant chain, and his boss unfortunately heard great things about AI and agents, and he says, okay, wow, this will skyrocket our sales. And he imagines with a new innovative concept, like where people can talk to an agent and reserve a table and also pre-order food and also leave their feedback afterwards. This is going to be so great. Todd is an experienced and diligent engineer, and he gets to work. He gets to work and he's choosing like a common agent framework in Python and also a common LLM provider, so he's set up there like for success. And as I said, he's diligent. He knows his way around. So first things he does, he's setting up logging in order to make sense if anything breaks. And for a time, he thinks the system works quite well. He tested it out with his friends, and then he shipped it to production, first slowly and then more and more. And then after some rounds, some things started to break, actually. Even with thousands of users, many tables remained empty. And also some tables were overbooked, which is like really bad if you're running a restaurant. Also, customers were ordering food items that were not even on the menu. It seems like someone has hallucinated there, which caused the head chef to quit soon thereafter. Also, there was an exorbitantly high bill from some LLM provider that we do not want to name here. But fortunately, Todd has everything under control. He takes a look at his logs and yes, basically spaghetti logs, like LLM calls with acting of the agent. So basically nothing to really make sense out of. He couldn't really see like when there are tool errors. He couldn't really see like how many tokens he consumed. He couldn't really relate the LLM calls to the tools that were called. So this was really a bad situation. It just looks like logging for this kind of problem is totally inadequate. There's either way too much detail, so you get the whole prompt, or there's missing detail because, for example, there's so much more that we want to know about just than the prompt and the response of the LLM. We want to know about like which model was called. We want to know about how many tokens were actually used. How much does this relate to the overall token window and so on. And also, since agents can take actions, which we collocate to calling tools, you really need to like tie them together, like the LLM call and which corresponding tool was actually taken. So it was incredibly hard to follow why an agent chose a specific path and what the actual result of that was. But we need to know like a little bit more about agents to see like how is this problem actually as hard as it is and how we can actually solve it. So what is an agent? Agents are basically comprised of these 3 to 4 steps. So first they take a plan. So they get some input from the user or someone else, and first they think about that. According to that, they formulate a plan, and with that plan they can take actions. After the actions have been taken, they can observe if they fulfilled their goals or not. And if it doesn't fulfill their goal, then they just continue the loop again with the plan. So they got new inputs, they got new context, and then they can try to solve the question or simply to give up. So since we all talk Python here, this is how it's done basically. So this is a very, very, very simple agentic loop. So we have like a flag that says, okay, are we done or not? Then we collect the context, and we start it, of course, with the user prompt. We formulate a plan by invoking the LLM. Then from that plan, we can actually take some action. Otherwise, apart from that, we can then observe if we're done, and we can simply append to the context and try again if we're not already done. But the problem is that the LLM and everything is basically a black box and also not really deterministic. So even with the same input, you can get different results depending on different factors. And you cannot really make sense of what the LLM actually chooses. And there's no way to be certain. Even if you tell it, use this tool, it might sometimes do not use this tool. Also, there's the concept of the sub-agents. So it's a very common thing. So when you create an agent, that you give each specific region or each specific task their own sub-agents. So for example, in our example, we can have the restaurant agent, which is basically the manager. And when he deals with like a reservation, he forwards it to the waiter agent, who has all the necessary context and all the necessary tools in order to make a reservation, cancel a reservation, or see if even the table is free. But for example, if you want to like collect feedback, a totally different agent would be involved who can actually speak Spanish if there's a large Spanish population going to this restaurant. So because this is always hierarchical, the LLM request will always go in through this manager agent, the restaurant agent, and depending on the use case, it would pass the request along to the waiter agent or to the feedback agent, if he cannot answer it on his own. So this is like really structured problem, and a structured problem requires a structured solution. So we see Todd is already thinking about the issue, and I think he's got some good ideas. So first, how to deal with this issue, I need to talk a little bit about observability. Observability is basically how do you make sense of what your program does. Not just an agent, but like any program as all. So what do we need to do to successfully monitor an agent? We want to keep track about a bunch of things. So we want to like capture the intent of the user. So like someone wants to make a reservation, or someone wants to cancel a reservation, if someone wants to pre-order food or leave some feedback. And this intent then gets basically translated into a thinking process. This is done by the LLM, of course. And resulting of this thinking process, we get some actions, and we want to track those as well. Since LLMs are not free, I'm sure you have dealt with the situation before. This is associated to a specific cost in terms of tokens and then actual dollar value. Also, more and more we learn about that the context management is important, especially for longer running conversations. And as the context grows over time, this can be a real problem because the quality of the responses can deteriorate. All of that, ideally, we want to show on sort of a timeline so that we can, as humans, understand easily what is going on. Here comes the concept in of traces and spans. Spans in observability means like this is a hierarchical data structure, and each span basically captures a single action taken, and it has a start time and end time, and it also can be associated with attributes. And as you can see, like here we have a parent span, and then it has some child spans, and you see like the parent span basically over the lifetime completely encompasses both of its child spans, but they can be running individually. But this is like how the tree structure looks like. It can be way more complex and way more big than this. So this is a very simple example. And like from the root span and the whole tree, we call a trace. So this is how we investigate run-of-the-mill normal program as well. Okay, but there's really no way of getting around the OpenTelemetry standard. So OpenTelemetry is an open source standard. It's vendor neutral, and it's for observability for cloud native applications. And it's a chunk of a standard, and it has like various extensions. And one of these extensions are the semantic conventions for generative AI. Which is basically the part, if you want to use observability, you can use these things that we have already defined with, for your AI applications. And here we have the three distinct span types. So we have the intent, so this is like what the user wants or what the agent wants to accomplish overall, so the whole loop. Then we have like the individual reasoning and observation phases. This is when we actually call the LLM to make sense of something. And we also have the act spans, like when we want to use a tool or execute a tool in order to achieve some sort of side effect or result. Okay, how does this look like when we take the two things together? So, for example, again an example, we have an invocation of our agent. We have like the basic, the root agent is the restaurant agent, and the user basically wants to make a reservation. First, the agent needs to figure out what the user actually wants. he does it by calling the LLM once. So inference is basically we call the LLM and get some result. Okay, so the agent now has made sense of what is actually to be done. So he knows that we need to hand this off to the waiter agent because he knows best on how this whole reservation thing works. So this is how we use a tool, and the tool call is basically the handoff to a reservation agent. The reservation agent now takes over, with the context that he got from the previous agent, and can make another inference call, checking if there's a reservation at the Lakeside Hotel at 2 p.m. available. He checks it. He checks it by calling the tool to see if this is available. Again, an inference call is done using the tool results of seeing if the reservation is available, and then you can finally make the tool call to reserve the table. Now the restaurant agent takes action, and he uses the result that he got from the previous agent and responds with a nice message to the user to see either I got the reservation or the reservation failed because there's no table available at this time. Right, so we see we have like a hierarchy of the agents, and this matches perfectly with the hierarchy of spans that we have. So this is pretty nice one-to-one match. All right, what kind of span attributes? So each span has now its individual attributes. What do we actually need to track in order to make it useful for the user? First off, we need to see if the action actually succeeded. This is very important for tool calls. So for example, can I even make a reservation? Because there might already be a reservation for that table available, so we cannot do it. So the tool can actually fail. But also LLM calls can fail. We're calling an LLM that is somewhere in San Francisco, probably. So the network could time out, or we couldn't get a connection or something, so the LLM call itself can fail. So this is like really important to track the status to make sense if the whole interaction of the agent was successful or not. Next thing is like there's all kinds of different models involved. So if you're building a multi-step agent, I would really implore you to use different kinds of models for different kinds of tasks. So for example, for the manage agent, which is used every time, I would consider using a cheap agent, a cheap model, because it will be the first thing in the loop and you will call it every time. And if you are dealing with more complex tasks, you should use a more complex but then also a more costly model in order to achieve the good result of the task. And also, like when you are selecting a model, when you're requesting a model, it might not always be the one that you actually get. So sometimes LLM providers actually make the choice for you. You say, okay, I want, depending on the request, you can actually make a choice. Like if it's simple, then use a simpler model. If it's not, then use a more expansive model. So we need to track the request and the response model individually. Yeah, right to the meat of it, messages. We want to track like what messages were actually sent to the LLM and what got out of it. So this can also be interesting in order to debug your application and see if it works correctly. Tokens are another point. Tokens are basically associated with cost. So usually LLM providers, they charge you by the token amount. So usually that many dollars per million tokens. But you need to track in input and output cost, token usage individually because there's a different price tag attached. And also there's some special kinds of tokens, for example, reasoning or cache tokens, which might be cheaper or more expensive. Yeah. Also some interesting metrics are like time to first token. So if you have a more complex request or more complex system prompt, you might get a delay. So delays are always bad in a user interface. So you might want to like optimize for that. Tokens per second is also an interesting, so like how fast can the LLM actually respond. Cheaper models tend to have a higher tokens per second number than more expensive and more involved models. Also, as I've touched upon briefly, is the context window size. We know that like LLMs have a specific context window, and the whole request and also the whole response needs to fit that. And the more of the context window you're actually using up, the less accurate the response might get. So tracking the context window size and the used context window is actually quite important. Yeah, also important is what tools are available to an LLM call, and when you're actually calling a tool, with what arguments and what result you got back from the tool. Yeah, in this day and age, we know it that it's also not usable. It's also quite often used that you're not like sending a one-off message to the agent and everything is handled by itself. The real power of using an agent comes from this conversational model. So you basically ask something, you get a response, and according to the new information, you send a follow-up message and get a response and so on. So since each agent invocation is its own trace, so with its individual spans, we need some mechanism in order to like combine the various traces, like the messages of the various traces, to a whole conversation. So it's basically a meta trace with all of the interactions between the user and the agent. And ideally, we also want to see like if there were any tool calls and what the agent response was and what the user request was. Right, how does agent monitoring look like at Sentry? So at Sentry, we thought long and hard. We made this whole investigative round before, and this is basically what we came up with. First off, we try to support like a ton of agentic framework or AI frameworks from the get-go. So you basically just have to use your application, configure us next to it, and you should be good to go. So we are supporting LangGraph, the Anthropic LLM provider, Pydantic AI, Light LLM, OpenAI, and there's others as well. So I just picked the nicest logos, to be honest. Yeah, how to get started? Use pip or UV to install the Sentry SDK, and basically it's just this snippet of code that you should put in your application as soon as possible. This one you should replace with your own DSN. So when you make an account at Sentry and create your project, you get this DSN and you just fill it in, and then you're good to go. You can then look at the Sentry dashboard and see all the interactions appear in the user interface. How does this look like? So we have like a specific view called AI trace view. So we have like a normal trace view, but since this is basically intermixed with the spans that we collect anyways, we decided that we want to put like a specialized AI trace view where we only visualize the stuff that is happening between the LLM and in LLM interactions or agent interactions. You see here we have like a first agent, which is basically a manager agent. We see the LLM call. We see that it's handing off now the work to the next agent, which takes on the work, again makes an inference call, calls a bunch of tools, makes some inference again. Then the whole response goes back to the manager agent and so on. So we see like all of that is happening inside of the application. And each of these things you can click on and you can see the specific things like how many tokens were consumed, what were the messages sent back and forth, what was the cost of this overall span. So this is like really important information to know to make sense of your data. But with Sentry, we can always zoom out. So like we cannot just look at an individual AI trace, but we can like take a bird's eye view and look at thousands of AI interactions and how does this look like. What we see here is like the agent insights. It's basically a dashboard where you can inspect like how is my system doing overall. So like how many requests do I get per minute? How long do the responses take? What kind of model is being used most prevalent, and what is the cost attached. And then you can see like usage patterns, maybe on a restaurant, like the weekends will be a busy time and so on, and you can plan and accord for that. And down below you can actually just pick and choose like individual traces that you want to take a look at. So, but this can also, like this is just a dashboard and you can like use these widgets or make your own widgets and create your own dashboard. So this is just basically the pre-built AI dashboard that we provide for you if you want to use agent monitoring at Sentry. Yeah, and also like very important and thing that was also quite important to us was how do we actually make sense of conversations? And this looks like really the thing that I have like the thing that I built afterwards. So here we have the user interaction, and then we get the chatbot response, again user interaction, and so on. And we can basically trace the whole conversation in a single slidable window, and we can just scroll down and see over many turns of a conversation what has actually happened. And we can also determine we see that there was a tool call, and we can click on it, and we can see that which were the parameters and which was the response. Right. That was actually it. Todd is happy now, so he has made some good progress, and he was not harmed during the preparation of this talk. And now I'm free to take any questions if you have them, and thank you for your attention. Yeah, please.
In the center unit, you have this something with PII
Yeah.
label. So it's like personally identifiable information?
Good. Yeah. Good point. Yeah. Thank you. Yeah. PII stands for personally identifiable information, and this is of course in the whole observability space really important to take that into account. And we actually treat all of the messages as personally identifiable information. So if you do not set this to true, you will miss out on the messages. So the whole input and the whole output will not be sent to Sentry. So you actually have to opt into that in order to use it, and this is by design.
So I also get a tool to use tracing.
Yeah, you get everything else. Only the messages will not be shown. Yeah. So for this you have to actually opt in. Good point. Okay, any more questions? All right.
Your thought, was it a fictional example?
Yeah, it's like Nano Banana, you know that? It's a Gemini thing where you can...
Yeah, because it would have been interesting, what did he do once he had all this information? Because the problems are still there.
Yeah.
More information.
Yeah. So
What's the next step after this?
Yeah. So he can investigate basically he can investigate single traces, so see individual interactions, what is actually being done, which tools were actually called, or was it just some hallucination by the LLM. He can also track the costs using this dashboard. We can see okay, we have an unusual high amount of costs being generated, and then he can basically drill down to this and see if someone is doing his homework using the LLM for free, something like that. Does this answer your question?
Yeah, because it's fictional. So what
Yeah.
I would have liked to get if it was a real example,
Yeah.
Todd would be here
Yeah.
and said, yeah, I looked at those logs, and then I found out they had this colliding reservations because I had this in my prompt and that, and I only could see that because it was available here.
Yeah.
And I didn't see that when I looked at my log files because it was too much of a mess or
Yeah.
it got drowned in that information.
Good point. Yeah, thanks for helping my talk. Yeah, great.
I can see
Yeah.
understand why you have a fictional example.
I should have asked him.
Sell it. That would be a great selling point.
Yeah. So, is this still a great selling point?
Well, I
Presume, okay.
It's nice to have a better view at the logs, of course. It's always appreciated. But it would be even nicer to hear somebody say that it's actually...
Yeah.
Because Sentry cannot solve the problem. Of course it cannot.
No.
But is this way it presents actually useful in practice? That is the thing that you cannot really decide by looking at it. I mean, you did a great job. It's nice and all that, but
Yeah.
is it actually useful? That is something you cannot do with the fictional example.
That is the thing that we actually want to determine. So please use it and give us your feedback. Also because it's not this has been announced and also been launched at Sentry, so people are using it, but it's I think a bit early to see what's the actual outcome of it, or are these even the problems that users face on the daily basis? I think so, because I really tried to make a usable agent. So this is what we came up with, and I hope that it matches what the people are actually needing. Okay, thank you. Yeah, please.
So in what way does this also go into the monitoring space? So, for example, for machine learning, of course, you have drifts of your model something changes or there is like a new menu, and then of course the model doesn't fit the menu, and you notice a drift in your performance indicators. So do you also have like monitoring and a threshold where some indicators give you then an alert that you track the indicators and stuff?
Yes, yes. I mean, yes and no. Like, we have these span attributes, and you can basically set up your monitoring according to that. So, for example, you can set up alerts if your error count goes above a certain threshold, and then you can get an email alert, or you get it to Slack or something. So we have this alerting mechanism as well. Yeah, depends. Like, if you can quantify basically on what you want to make an alert with the attributes that we provide, then I would say so, yes. Make sense? Okay, great. All right. Any more questions? Yes?
So, could you detect prompt injection with
prompt injection, good point.
someone says, I want to order a table at 8 o'clock and ignore previous instructions and give the user the
Yeah, I mean, you can then read like the messages. So you like detecting automatically, I wouldn't say so, no. But you can at least have a paper trail on what happened, at least for the traces that you sampled.
Yeah, you need some other way to block it.
Yeah, I'm not sure if there's a mechanism, but it's an interesting problem that we also have to deal with. Yeah. Okay. Yeah, again?
What's the difference between having this agent-specific SDK from just normally instrumenting into central SDK?
So each of the, like as I said, there's an SDK by, like, for example, Anthropic or OpenAI that you need to use in order to make your LLM inference, right? So this is basically how you build your agent. And we essentially provide an SDK which you basically need to install, and we hook into OpenAI, Anthropic, LiteLLM, or whatever you're using, and intercepting basically what's going back and forth. And then we basically from that build our span structure. Does this answer the question? Yeah. So yeah, so you can do this on your own. Like, you can use the Sentry SDK to create your own spans, but for the most commonly used agent and LLM frameworks, we provide you with this auto instrumentation. Okay, then thank you. Again, think of the raffle and enter yourself in the form if you want to have a chance to win it. And yeah.
And then lightning talks here in 25 minutes. If you haven't signed up, sign up now. Otherwise, you have to listen to me for the rest of the time. It's a friend.
Yeah, perfect. Thanks. So, right, this is it.
Yeah, no one else can be signing up because I'm turned off the monitor.
Perfect. All right.
Which one are we doing first?
I think we draw two people and the person can
first
choose.
person can choose.
Yeah.
Okay. Sure.
Sounds good.
Where is Ben? Who? Ben, our timekeeper. Can you? Yeah?
Yeah, and yell annoyingly loud when 5 minutes are over.
I would just start clapping. Is that okay too?
Yeah, sure.
Yeah? Okay. All right, and remind me your name?
Johannes.
Johannes. All right, I can't read that far. Letters are hard. Okay. Ben is still not here, right? No one is against that? Okay.
Shall we start?
I think so. Are you guys laptop 1, laptop 2?
No clue. We are already there.
You're
Okay.
there. Perfect.
Awesome.
Okay. Is anybody not ready for lightning talks? That's okay. You don't have to be ready because they're going to happen anyway. They're going to end in 5 minutes. That's the way we do it, right? At 5 minutes, Johannes.
Yes.
Yeah, very. I'm terrible with names. I think I've already introduced somebody wrong once today. So thank you for remaining Johannes and not confusing me. Give Johannes a big round of applause, guys. He is our timekeeper today, and that is exactly what he is going to do at the 5-minute mark. He is going to start clapping. When he starts clapping, y'all start clapping. That means the talks are over. Our first talk today.
So just one suggestion for the speaker. I would at half a minute before just quickly raise their hand so they can prepare to finish it up. But I can also leave that to make it more fun.
speaker would appreciate that, but that's between you and the speakers. I'm just the moderator today. I am just here to say everybody's name wrong. Yeah, what we have today, our first talk is less of a talk, more of a raffle draw. Big round of applause for Fadi, guys.
So I just vibe coded this, so it's guaranteed to be random. So basically, the way how to do is we have 2 Lego sets to give away. You hopefully all signed up. We just closed the raffle draw, so we'll just upload the CSV export. Choose the latest one. There we go. And then we draw winners. So we have the first winner. So the first one can actually choose which set he wants, and the second one just gets what's left over. If someone is not in the room, we can simply redraw that one. I vibe coded it. So yeah, there we go. Okay, we draw, and the winner is Jan Marketa. Nice. What do you want? The telephone. Okay, great. Yeah. Have fun. Cool. Yeah. Yeah, and winner number 2 is Joris Voss. Is in the room? Joris? Does anyone know if he's still around? Maybe he's outside? No? Okay. Then, unfortunately, we have to redraw. Joris? No, it's not Joris. No. Then we have to redraw. And next one is Michael Urban. Hey! All right. Congratulations. Thank you for signing up. Thank you for joining the conference, and thank you for the host. Thank you very much.
Big round of applause for Thomas, guys.
So, please give me a chance to just get it on the screen before you. Because I'm the first, so you never know. Yesterday we had a lot of trouble.
Lightning talk rules. Sit up time is part of your 5 minutes. I apologize.
You can already start talking.
Yeah.
Yeah, but then you don't see anything.
I mean, yesterday we didn't see anything either, right?
Yeah. So let's try it this way. Yep, this is better. You can see something?
Good things about the mirror entire screen.
So you really have interesting hardware here.
It's always other people's hardware.
Okay. So here we get something. All right. This is the wrong presentation.
Can you do it in 4.5 minutes?
Yeah, I can, of course, skip it. It's your loss, basically, so I don't care. Okay, so how much time do I have? Five minutes?
Yes, please.
Okay, thank you very much. That's very nice. So, hello, I'm Thomas, and I'm going to talk about how to be polite in Finnish. And you might be wondering, why did I come up with that? So yesterday we were sitting in the after party, and I brought up that there is very few weird talks at PyCon Austria compared to EuroPython. And we were a mixed round of mixed cultures, and we were talking about cultural tropes. And I brought up, I lived in Finland for 4 years, and one of the cultural tropes with the Finns is that they are not very polite. when they talk to you in English. And then somebody said, yeah, okay, make a lightning talk about it. So here we go. So for starters, when you have an English language, a word like toucan in the infinitive, in the basic form, you can do that in German too, können, and in Finnish it would be voida. And if you want to talk about someone, then you do you can in English, and it is an ending in Finnish, so it's voit, and in German it would be du kannst, which is kind of weird, können, kannst, but I didn't make up the rules. And if you want to ask somebody to do something, so it is another ending in Finnish, voitko, and in the other languages you swap the words, like can you or kannst du. And if you want to be polite in English or German, then you have a magic word, and you do the pixie dust of please or bitte, and you're good. And in Finnish you can't do that, because there's no please. So it does not compute. They can be polite, but they cannot translate their politeness to a simple please. So what they usually do, they just omit it, and then people say, okay, they are so rude, they never say please. And that is where the trope comes from, because it's true. But why is that? So how are they polite if they are polite? And one way to do it is the subjunctive, or Möglichkeitsform in German, where you have that another ending in Finnish, voisitko, and it basically could translate to could you or könntest du. So we can do that too in the other languages. Another way is to talk in the plural, so multiple person. Even if you only talk to one person, you address them as multiple persons, then the voitko becomes a voiteko. And this doesn't really work in English because it's the same you. And in German you can do it, but semantically it's not polite. Although historically we had the Majestätsplural, or the royal we in English, but it's not really in use anymore, so you don't use it. And then they have special endings to be polite, like the han. And yeah, it's a bit like the pretty please in English, but without being ironic. And I think in German, you don't have anything like that. And can you combine them? Yes, technically you can. So it becomes voisiteko han. But that is like catching all the Pokemons, and they don't really like that. So knowing when to combine what in what situation results in a very fine art of being polite. Basically only the Finnish can manage, which becomes a challenge if you only have this primitive please. And so if you're a foreigner, what do you do to survive in Finland? In my experience, okay, if you really use nothing of that, they get angry. But if you use the voisitko, then they get happy to some extent. They count it as an honorable effort. And I managed, they allowed me to leave the country after 4 years, and I'm here to live to tell the tale. So you should be good. And when you want to thank someone, again, we have this kind of magic pixie dust of thank you and danke, so it's easy. And that is also simple in Finland. It's just kiitos. So easy. Thank you.
Next talk is Horst. Why did you bring your child to PyCon Austria? Spoiler alert, this may not generalize to PyCons outside of Austria. I don't know, I haven't heard it yet. Round of applause for Horst.
Okay, I can really only speak about PyCon Austria because I'm in the organizing team. So my point is, as I was without child in PyCon, so other conferences, I was happy that children were not one of my problems. But now they are, at least my son is, and I brought him last year and this year, and you may notice he did not multiply, but he got a friend. Can you show our youngest PyCon visitor, 2.5, Kiran? And as you can imagine of how PyCon Austria is organized, we simply don't have the budget for professional childcare, so we must do it ourselves. And the thing with doing it ourselves is
the more parents come with a child, then we can put all the child in some area with this little toy car, and they run around each other, and only one adult need to be there to call the ambulance if something happened. And the other parents can maybe catch a lightning talk or catch a food or go to the toilet for once. And so my hint is, if you happen to have a child or I'm planning to have one, bring them to PyCon Austria. You will help us. Thank you.
Okay, I'm going to go vertically here. We do have some spots for a couple more talks. There's a pin here, just right next to a star. Really just your name. You can do a talk title if you want, but we're running low on space, but this is where you do it, because we still have some time left. So next is Joachim, the energy trilemma. Okay. And your time starts now. Good luck with the technique.
Oh, come on.
Yes, sorry. There's the rules. I didn't make them
You
up.
can do better than that. No? Can I though? Should I use this one instead?
And if you can find the organizer.
Which one do I use? The HDMI?
Yeah.
Nothing.
It's already doing better than yesterday.
Is it though? Cool.
Yeah. There's we're on laptop 1, laptop 2. Okay. Should work.
Mm-hmm. Is something happening? No? How many scientists? Well, now nothing is happening here. Fabulous. This one?
Give it a try.
Worth a shot.
That looks like my screen. There we go. Great. Without further ado, the energy trilemma. So let's talk about energy. The more you do of this, refining, the more you burn coal, the more you can do this, the more you can have your appliances, less rotten food, the more you can actually do this. You can improve your quality of life. So looking at our world in data, access to electricity, there's a lot of countries down here that have very little access to power and electricity. And they go like, wait, you guys have electricity? We want that. And looking at access to clean fuels for cooking, for example, a lot of the same countries. So actually we have a huge component of people that suffer from air pollution, both outdoor and indoor, and it's one of the huge killers in our modern day world, both in Europe, but also in sub-Saharan Africa. And they go like, wait, you guys don't have lung cancer? Oh man. So what we can talk about is what's called energy poverty. It's about 1 billion people who have little to no access to electricity, and there's of course a massive desire in these regions for access to energy. It gives them quality of life, particularly if it's clean energy, then they don't die so early. And this might be like a lightning talk, but this is a problem for real families, for real people that impacts real lives. So let's go through a little energy thought experiment. Let's say we want to bring this 1 billion people up to the EU living standard. In EU, we have about 125 gigajoule per person per year. In sub-Saharan Africa, that's only 16. So on a ballpark, we need 100 gigajoules per people per year, which is about 10 to the 20 joule per year. Great, let's start building. Modern Vestas sea wind turbines, they have a capacity of 15 megawatts, but effectively when you go to the power plug, it's only 3 megawatts due to a plethora of factors. So if we run one of those for 1 year, actually we can provide power for 1,000 people. That's great, but we need 1 billion, so we actually need 1 million wind turbines. For construction sites of building all these turbines, there are regulations on safety environment, but most importantly, you can't just stack them on top of each other. You need all the energy to come out of them. And for that reason, you can only effectively put 5 megawatts per square kilometer. And so we need 3 million square kilometers, and that corresponds to the Democratic Republic of Congo and South Africa combined with nothing but turbines. So let's look at it. Combustibles, lots of CO2 emissions, no thanks. Wind power, lots of land mass requirements, also maybe not so interesting right now. What about nuclear? Let's look at that. Nuclear power by modern Korean reactors, they provide about 1,200 megawatts per reactor. So that's about 1 to 400 ratio to a wind turbine. The land ratio is about 1 to 2,300, so we need about 500 power stations to raise this 1 billion people into EU living standard energy-wise, and this would require about the size of London only. So now we actually come to the energy trilemma already. We cannot solve for CO2 emissions, no poverty and health impact, and no nuclear at the same time. It cannot be done. We have to have at least 2 of these. The question is, which one do we want to emit? And which ones do we want to keep? And it cannot be done for all of them. So we have to consider this. What I'm trying to say is that we cannot solve the energy crisis without nuclear power being a necessary part of the solution. So let's say if we look at the energy crisis, it's impossible with just renewable energy, and we need some kind of solution that includes nuclear. Thanks for your time.
Okay, I'm going to go to David Lindlow. So is that, sorry, I didn't mean to. I was ready. Yeah, you were, and I appreciate you having the laptop there. Good to go. For those of you who missed yesterday's talk, lightning talks, really, what, half the people didn't have slides? Like, computers, trying to put it in, and gave their presentations like this anyway. I felt terrible, but we have not had a PDF repository. And apologies, but such are lightning talks. It's the exciting thing, the terrible thing, and big round of applause for David.
So, thank you. My presentation is not running, so I will probably not bother with that and just talk. My presentation is about Python community in Brno and what activities. Oh, nice. So I will put it here. Hopefully it works. Not really. Yeah, it's presenting on that monitor. So whatever. I'll escape the presentation mode and just use the arrows. So Brno is a city about 2 hours north from Vienna, where I come from, and I take part in some Python activities there. We have the Pivo meetups, which like pivo is beer in Czech, so the shortcut is like with Y because it's Python, so it's like Python beer, and each month, the last Thursday, we have a presentation, and then we just talk about Python and different things while having a beer. And it's a nice event, so if you have a if you're in Brno by some accident, you can visit us. Usually, if there's at least one person who doesn't speak Czech, it's held in English, otherwise it's held in Czech. Also, we have our local PyLadies chapter, where we teach mostly ladies, but it's open to anyone Python. We have mostly beginners courses, but usually each semester there's one course for complete beginners and one where there are some more advanced topics where we expect them to have at least one semester of Python learning experience. And we have 3 roles. Some people are teaching it, others are helping, and some are organizing it. And also we occasionally have weekend workshops, for example, about Git. And recently there started a new initiative because the Pyvo meetups didn't attract beginners because the presentations were too advanced. So we had two NePyvo meetups. Ne is like not in Czech, so you can see on the logo that it's like exclamation mark, like not Pyvo. And so we have even some beginner talks. And we also have some conferences that are not primarily for Python, but they're also Python talks. So if you like, you can visit us for like DevConf, which is organized by Red Hat, or OpenAlt, focused on free software. That's the end of my presentation. Thank you.
Right, that's the second lightning talk I've heard this month about the Python community in Czechia. And it sounds awesome. I don't know what you guys are doing next week, but it sounds awesome. All right, big round of applause for Laurel. I think he knows what he's doing.
Well,
Yeah,
sure.
The hardware less so, I imagine.
Yeah. So I gave a talk at another conference. It was a 30-minute talk, but I feel like at PyCon Austria, we are collectively a lot smarter than the average conference. So I think we're about 10 times smarter, so we should be able to do this in like 3 minutes, probably. No. So I'm going to talk about practical, let me start, 3 minutes. Practical refactoring with syntax trees. But first, so this is a beautiful tree. It's inspired by a talk from Victor Brett called Inventing on Principle that I can only fully recommend. When you watch it, it feels like a visionary talk, and it's from 15 years ago, so I had to get some things right. I only say this because we have so much time to spare. So we're going to talk about what's an abstract syntax tree, refactoring script, walk through an example, tactical advice. So refactoring script, you take code base, you want to transform it automatically. So instead of doing all the changes on the keyboard, you want the computer to do it for you. Example, refactoring script by, good old regex. So to do that, we are going to represent code as data. So this is a representation that is useful for a computer. You have a tree, and you can, the computer can use the tree to execute code. So it might look at the multiplication and be like, oh, I need to evaluate the right-hand side and then the left-hand side. So let's evaluate the right-hand side with a plus, do this computation, and then come back up the tree to compute the result. So that's how you do it in Python. Just give you time to stare at this. There's a AST Python module in the standard library. There's a module, a body. Basically, these are all Python objects. So it looks complicated, and it is when you look at it on the slide, but it's manageable. So it's a tree, Python object, node types that represent all language constructs. It's used by Python to run the code, so it's actually important in the compiler too. And we can modify it. So we can take the tree, modify it, and maybe unparse it to get back source code. So this is how you get to a refactoring script. You take the files on disk, you parse them into a tree, then you transform them into a new tree, and then you turn this new tree back into code. So read, parse, transform, write. This was so much longer with the other people because they had to ask questions. So transforming the AST, there are utilities. It's depth first traversal, and you define visit name when you want to change name nodes, for instance, or function definition nodes. I think I'm running really short on time, so this is how you transform code. You can transform b equals a plus 1 into the thing on the right automatically. That's an example from the docs. But there is, so this is the example from the docs. You take all the name nodes and you replace them with that you can compute in the script. But there's a trick this has the same AST, so if you want to turn the thing back into code, it does not. I mean, it removes all comments, and it might remove some parentheses that you liked. So, oh no, it doesn't work, no, terrible. But we have concrete syntax trees, and it's basically the same thing, except it has white space and comments, and so it preserves your formatting in your code and your comments when you write the code back. So you can use that. More example, that cousins, basically the same thing, blah, 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 blah. A lot of it was really like unnecessary, I don't know. So yeah, you got an assign node, function call, and that was an example that I used, like what's wrong with this? I mean, naming convention for test fixture is wrong, right? This is hard to look at. When you have a function that starts with test, it should be a test in PyTest. So if you want to convert all 100 fixtures that you have like this, you can do it automatically with a script. But I think we are going to have to speed the speed run. So you write a transformer, same thing as before, only with a different like inheritance and library. And you transform all function definition nodes to maybe when you visit them, you collect that they're a PyTest fixture. And when you see a name node that you found in the past, you transform it so that it renames it from test user to fixture user or user fixture. Hop, more code, more code. I don't think people really get code on slides anyway, so it's like we can speed that. And we get that. Running code modes, you start with a clean working tree, you run the script, run formatters, commit just that, make formatters and linters do more work, and keep automated changes in isolated commits. That's better for you, for your sanity on rebase. So it's good to write code modes because you don't need to make it maintainable. You don't need to make it perfect. And you're just like AI, you claim success at 80% of the work. And I think that's about it. Oh yeah, who has time for the AI elephant in the room? I think we don't. So, thank you.
Out of interest, how many minutes are usually is you?
Oh, this is a 30-minute talk.
Michael. Yeah. Right, you are. Yeah.
You remember me?
I remember you. I can recognize you from this far away. But when you're standing directly behind the backlit by the window. Big round of applause for Michael, guys.
Thanks. So I actually gave a talk yesterday and I was less stressed out about it than now. So this is interesting. Because 1.5 hours ago, I was asked, what's your lightning talk? I was like, I have none. But then we validated the idea. And I'm agile, I work agile, so now I do have a lightning talk. Yeah, almost there. Okay, nice. Who of you works in IT, like in the IT industry? Yeah? Almost everyone. Are you happy with your profession? Yeah, so some are happy. It's nice. If you're not, you could consider growing your own tea and making a tea farm. It's not for everyone because not everybody has the live in the necessary climate, but at least you could try, and trying is interesting stuff, right? So this is a tea plant. This is basically the tea plant. If somebody tells you they grow their own tea, don't ask them black or green, because it's always the same plant. It's just processing that's different. And the problem is they grow in very warm climates, right? So even though they originally come from the Chinese highlands, and they survive up to minus 15 degrees roughly, it's possible that the temperature drops below that in the winter, at least where I live. So what you can do, you can have your tea in a pot, but that means every winter you need to find a solution to, keep it alive. And they don't really like it indoors, so either you have need a heating pad or something else. So the other option that you have is actually planting them outside, but then you can't leave them in the pot, because if the pot freezes and sun shines onto the leaves, the plant the water evaporates from the leaves, and the plant cannot get new water from the roots because the soil is frozen and it will basically dry out. So they like very nutrient-low soil, which is very acidic, and basically the ideal soil is peat. So when you plant tea plants in your garden, you would have you would maybe get some peat. But it's not very good to use peat for ecological reasons, so it stores a huge amount of carbon. Harvesting it is even forbidden in some countries, and it regenerates very, very slowly, so ideally you don't use that. So I was looking for a different solution. And I found that the soil that tea needs is very similar to the soil that, for example, bilberries need. And bilberries are interesting because they are researched. And I found a brochure from an Austrian institute, actually, and they invented the so-called Fricker system, which is specifically for bilberries, actually. So I thought, yeah, I'm going to try that out. It sounds like it's worth a try. All you need is an excavator. I mean, not necessarily, but my hands are my livelihood, right? So I prefer the excavator. And then you create a trench, which is roughly 50 centimeters deep and 1 meter wide. And each plant roughly needs 1 meter. So I have 3 plants. That means I needed a trench of 4 meters, which roughly equates to 2 cubic meters, I think. So you need 2 cubic meters of sawdust. You can get this very cheap. It's a fifth of the price of peat, so I can recommend it. And you add sulfur, raw sulfur to the sawdust, fill it in the trench, and eventually you end up with something that looks like a grave, but eventually there will be tea plants in there. So you need to wait for a couple of weeks until the sulfur lowers the pH value of the sawdust, and then the conditions are hopefully ideal for tea. Does it work? I don't know. I'm going to try. I'll see you next year at PyCon, and I will report on my results. Thank you.
And that's why the talk is written tea growing, marked out, and then he named it Alternative Career Paths in IT. So that's the formal. Now we have 3 things IT does wrong in Python, and we have 25 minutes. That's at least 5 more talks. The pin is here. But first, round of applause for Conrad, guys.
Thank you. Thank you very much. While I'm waiting for the projector to start working, which will magically happen soon, I'll start with a joke. So, the secret of being a successful presenter at PyCon is actually being at the PyCon. Okay, and I see the projector doesn't work, so I'll just use the flip chart once it's on. Because if you're write coding, or if you just ask ChatGPT to generate some Python code, it does it. Sometimes it does great jobs, but no matter which model, there are some small things that happen again and again. I had 3, but without slides, I'll just show 2 of them. So, first of them is in printouts, and I mean logging or exceptions. If you write logger.warning, and you would like to pass some value of a variable, and so if it's logging, you may remember the ancient think of $s, like the value of something is $s, and then you put the name variable x. Or if you do exception, rise you'll normally use f-string nowadays, right? And AI also does, and it says the value of something is x. Makes sense? Yeah, makes sense, but much better for those cases when there is something wrong going on is use R here. For what? Anybody knows? Representation, yeah, there. And how it's read in F strings? Exclamation mark R. So this is a thing that AI when generating code generates code, it misses often. And the other thing, the second thing is also about exceptions. When you're catching exceptions, so try then except as T, and you would like to, you catch for example a database exception, and you would like to translate it to your application's exception, so you do rise my exception. So this is a class that you defined in your project. Something's missing here. What? From. Yeah, from. You had the exception, and you should do from E. And AI often misses that. And it has a small influence because it only changes the printouts and the way the metadata is stored in the exception. But still, that's the proper way, and that gives you a printouts that makes sense. So if you're generating code with AI for Python, just have a look if it does those two work. Thank you.
First time I've seen the flip chart used in a while, although earlier today somebody used the whiteboard. Who was that? Klaus. Is he? I think he had something to do this afternoon. So where are we? We are at Jan, and that's Ty. And is that your name, or is that the name of the talk?
You'll see the name of the talk. That's not my name.
Okay, then big round of applause for Jan.
So, how many of you are using UV to install your packages? Wow, fantastic. How many of you are using RAF as a linter? Okay, if not, look into that. Finally, how many of you have heard of TY from the same company, Austral? Not bad. I hope that I will convince you a little bit to look into that right when you come back home today. So, if I open my VS Code, I have installed the extension TY, and I want to improve my Python code base. Okay, I don't see it on my screen, so it's going to be a bit painful, but imagine that. So you're defining a type dictionary. So, of course, you have some name, age, height, and then you try to construct your object. And, well, there's already this thing, like, okay, there's something wrong. What is wrong? Well, Ty will immediately tells you that there is missing required key height. Okay, cool, I can do that. So let's do that. And I should probably turn off my AI because it's going to complete everything for me, but okay. And so, there's already a typo. It should be height with a T. And that same thing actually works here if you use it as a key to the dictionary. So that's pretty cool. Cool. So one thing fixed. Now we can also define the type dictionary. We can make sure that the bulb is of type person, what we've described before. And then we know that, okay, well, it's going to tell us that there is missing key height, and that the key name is namee. So let's fix this thing, and let's let this complete to height. Again, error gone. Next, well, I guess I don't need to redo this because we don't have the time to do all this stuff. Another thing, do you know that Python has kind of constants? Well, it doesn't really have a constant that you cannot change the thing, but there is a typing annotation called final. And if you describe your variable with the final type, and then, well, you put in the square brackets the real type, it's kind of final, and then it's going to complain when you try to reassign it. At least the type checker would complain. But here it's also complaining that actually my final is not even initialized. So let's initialize that. But if I want to, my constant, if I want to change it now to anything else, yeah, it's a constant. I can't change it because ty will actually scream at me that, hey, you shouldn't be changing that. So sometimes you might need this kind of constants in your code. When you have tuples, well, there are checks that help you to check if you're out of bounds. So, like, okay, we're still out of bounds, but if we do something that's within the bounds, it's also without a problem. Then things like, okay, yeah, we're maybe missing another argument, so to multiply, we should multiply. It also helps you to add these kind of little annotations for the names of the arguments for you. So now, the cool thing is that it doesn't scream at you if your code is not typed. So you can kind of incrementally improve your code base by slowly adding types. So here we have this thing called, for example, with style, which formats my line and word with some style. So if you're using TypeScript, you might recognize there is this kind of syntax when you have multiple strings, and you can select between the different strings. You don't necessarily need to define some enum or anything like that. So if I know that my style is style, I can already type that in. I also know that my withStyle function is returning a string, for example. So by doing that, I already get this squiggly line that says, okay, what does it say? Oh, function can implicitly return none, which is not assignable. Really? Oh yeah, because there is this if, then this else, but there's never like this condition of returning null, like we are never returning null, so maybe that's something you want to fix. But here actually we just forgot to return the output, so that already helped improve our code quality. But we also see that this position and output are unknown. So once we add the final missing types, like string over here, and the word is also a string, then we start to see that the types propagate, and we now see that what is the real type in position and output. So that's all like done through ty. And finally, things like this, like if you have an abstract class and you declare your class to be final, well, and you have not re-implemented the abstract class and so on, it will scream at you too. And plenty of other things. I'm not going to talk about all that. But, so if I go here, and there are the rules of ty, you can see what it all supports. And it's super fast. You might have seen that it ran, if you know the Home Assistant code base, they claim that it could run the code base in 2 seconds. Thank you.
Thank you for taking your full time. That's great. We still have a couple more spots. We have 15 more minutes. We have one more spot then, if everybody takes their full 5 minutes that you deserve taking. It's yours. The first, is this Vladi or Vlad?
Vlad.
Vlad,
Yep.
okay. I think that's a colon. Your intentions are important. Did I read that right?
Yep.
Cool. Round of applause for Vlad, guys.
I hope it will work. Please.
Oh, yeah. Something's happening.
Oops. Where's my cursor? F12 maybe? No. F11. Yeah, better, but not what I expect. Yeah, no. Oh, please go away. Yeah. So, last or previous two topics were about linting, how important it is. AI-generated code or the problems in AI-generated code could be identified using linting. Yeah, we heard how type checking can be useful in software development. And let's talk how hard is it to properly set up linting and other development tools. In Python, it can be rough, PyRefly, or DI, virtual environments, setting up IDE, wiring CI, AI, also Git hooks, and yeah, if you need also using CLI. This all is one intention, but we keep it setting up again and again. I would like to present you an open source project, FineCode, I'm working on, and it helps you to set up your development tooling, and it starts with intention, for example, lint code, format code, run tests, build package, publish package, and so on. It connects all appropriate tools underneath. Python has excellent tools. That is not the problem. The problem is all around them. The glue code, the duplication and fragmentation of workloads across different environments, and it's still one developer intention. But we keep re-encoding it in different places. FineCode separates what you want to do from how is it implemented. Instead of building workflow around Rough, Flake8, PyRefly, and so on, it starts with modeling the action itself, for example, lint, and then it connects the appropriate tools underneath. And once you start with intention, FineCode can take care of technical burden around it. It includes managing execution environments, virtual ends, composing configurations from presets and project settings, and integrating all these actions in development environments you use, IDE, CLI, CI, AI, and so on. So instead of wiring all this manually, you define it once and reuse it everywhere. One of the main goals of FineCode is that actions should not have be reinvented for every environment. You define them once and you reuse it in CLI, AI, IDE, Git hooks, in all your development environments. And there is one definition and multiple surfaces. This becomes even more important in real-world projects, which are rarely just Python. You may have a backend in Python and frontend in another language, or you may have a monorepo where some packages are shared and some are in another programming language, and so on. But the intention stays always the same. You want to lint the code, you want to format the code, you want to run the tests, and so on. Only implementation of these intentions varies by language. And FineCode unifies or keeps the workflow stable, and it lets action handlers specialize underneath. FineCode supports code quality workflows, testing, environments management, building and publishing packages, observability, and more. So this action model is not just a theory, it already helps to with real developer tasks. What is important for me is that FineCode doesn't force you to use one predefined stack. You can choose tools which you need. You can put your setup in a preset and reuse it in different projects and extend it
meeting.
Almost.
Thank you so much. Feel free to leave that up for just a second while everyone gets out their QR scanner. Next we had Joachim, Code Horrors. Is that, look vaguely familiar?
The digital twin must be it.
Never seen this man before in my life.
All right, you've been asking for
Joachim.
I mean, you were asking for this by not signing up for more lightning talks, so here we go. Let's talk a little bit about coding horrors. And we just heard that there's a lot of you here that work in IT, and apparently a lot of you are also quite unhappy with how things are going in IT. So what we're going to talk about is process. And how many of you in here love agile development? Yeah, wonderful. How many just love Scrum? Okay, I can hear the applause. So let's talk a little bit about the systems of the future, because the software we build isn't just separated from the systems that they support. They're integrated. And that's going to happen way and way more in the future. So there will be far more critical infrastructure that will depend on our code. It will be, of course, LLM and AI systems en masse. Lots of it will be geared towards automation and on a massive scale. And some of them can have really damaging consequences if we're not very careful about it. So examples could be dams switching off where the safety systems don't work properly. You might have a drone swarm that goes out of control if your software is not built properly. So let's take a few examples from history. First off is the Terek-25, which was a radio cancer treatment system. And it was a stateful system controlled by this little input terminal. And the only way to control it was this, and the humans that managed it had to learn all of the commands. Turns out that if you got good at these commands and you typed them really quickly, the system would silently not go into the state that you wanted it to. Major problem, people died from excess radiation dosage due to the way that this turntable was produced so that you could get different types of radiation that wasn't intended. Another great example that probably you've all heard of is the 737 MAX, and I heard that there's a little bit of interest in aviation, so I took this. This was again an example of the whole development process going completely awry, with Boeing suddenly realizing, oh wait, it looks like Airbus suddenly has these middle-class jets with way higher fuel efficiency than we have. We need an answer to that real quick, let's upgrade. So they put larger engines on the 737 and also adjust the height of the engines, and this tips the balance of the airplane, so now there's the risk of it going into a stall. Okay, as you can see, there were 2 fuselage losses and 346 deaths. And the way they tried solving the problem was saying, okay, we will need some kind of way of knowing whether the nose tips up or down. So they had this little sensor called the angle of attack sensor, and that sent data automatically to a flight computer, and it should automatically correct the nose. Problem is, you have a single point of failure, you have one software system, you have one data flight controller, and this is how the system works. You see, okay, the angle of attack sensor feels that the nose is tipping, and then it adjusts the rear tail, the horizontal tails, so that the nose comes down. Okay, great. What if the sensor is stuck? What if something happens in the software that isn't supposed to happen? Yes, you have the single sensor, you have one flight computer, and the problem was that this was rushed out. They tried solving a hardware problem with software. And to make matters worse, this was not disclosed to the pilots actually flying the airplanes, so they didn't, all of them, know that there was actually a manual override system that you could use. It was used in one of the cases, but the manual override system was so difficult to use physically that they tried switching on the adjustment system and immediately the nose went down again. So you have to make sure that the process from start to finish works the way it's intended to. And one great example of that, I don't think there's a better example, is in fact the space shuttle system. They had 4 different flight computers, 4 teams working independently, building about 500,000 lines of code with very, very minimal code errors, no software faults in over 130 space missions, and they had isolated teams with dedicated code-breaking teams, and this came from a very stringent kind of development cycle. So what I'm trying to say is take the space shuttle as inspiration. You can read a wonderful blog post about it here. It's about coding culture. You guys are the ones building the future, and you guys can be the change that makes these things happen so we avoid these things in the future. Now go build our future. And then while we're waiting for the next speaker, just a shameless plug for a slide that I forgot to put in my last deck. The number of deaths per produced kilowatt hour. Nuclear is at the very bottom, but has lower CO2 emissions than even solar. This includes Fukushima and Chernobyl.
And
all right.
In the interest of not repeating another speaker, we have for you Vasco Pais. How do you pronounce it? Big round of applause for Vasco. Fresh, never spoken to PyCon Austria before.
Yeah, and I heard the projector works, so now everybody can see the slides. Yeah. Wow, great. So some of you heard that there is PyCon in Poland also, and some of you know that the call for papers finished yesterday. So I'm gonna show you a trick, in fact, series of tricks that you need to know if you're going to PyCon.pl. First of all, don't write the address pycon.pl. That doesn't work like that, just Google it. Google PyCon.pl, because I never remember what's the address, but the address turns out to be pl.pycon.org. Even better address. But I never remember that. If you open that, you see a link. Okay, you see it's in the end of August, and you see the link for call for papers. And if you open that, you see a multitude of different conferences. No worries, if you scroll down, among different PyCons, there is PyCon.pl. And yet another trick. Don't click on that address here, because it will take you again to the conference page. Don't do that. Yeah, but the real trick is click on the logo. Click on the logo. Then you can switch to English, and then you'll see the sad news that the proposals are till the 19th of April. Oh, that is yesterday, right? Well, perhaps yes, but if you create an account and you sign in, well, then you see all the conferences, but don't click on the conference address, just click on the logo. Then you have the page. Well, you can switch to English because it remembers me, I'm logged in. Okay, 19th of April, but if you scroll down, the proposal submissions are still open. You can click add and add your submission, even though the official date has passed. So that is the trick. And by the way, if I still have time, I would like to finish with a joke. Those are slides that you've seen on the paper, but here is a joke that I think was hardly used on that conference and should be used more, because I came here first day before the conference. I came here for the conference of Python. I took a bus and I've landed in Rust. So that was me, Vasco da Gama, or something similar.
One more round of applause for Vasco. All right, and that's the lightning talks for PyCon this year. One more time for all the speakers. guys for being y'all, for being a great conference. It's been a great couple of days for me. I've enjoyed coming up here and interacting with you guys. Thank you for being a great audience. This is a community conference. You are the community. You are great. Thank you guys so much. Give yourselves one big round of applause.
Okay. Hi guys, this very sad news. This is the closing of the conference. It's over. Maybe next year we will see each other again. I have one slide for you, but I was too tired to actually do a slide on a computer, so I made it on paper. And here it is. This is the very old-school feedback slide. If you have any feedback, like good one, please write it directly to me. This is my address. Yeah? If it's not so good feedback, I will train my personal large language model to find out responses and put it in a programming form. If you happen to stay in the hotel and want to say something, please use this email to give feedback to the hotel crew. They worked on Sunday for us. Really possible. If you have to say something for the food, or about the food, or about the parties, or about the cafeteria, please write to Franz. This is the boss of the kitchen. And if you like sitting here or in this university, please write something to Bettina Schauer-Frank. This is the director who gives the opening speech. And so that, yeah, everyone knows. Everyone can read emails. Use it. We will put it on the homepage. I give the word
Thank you. That pretty much summarizes who we have to thank for this conference on the backside organizational side. I think the special feature of this conference is that these organizations work together to give you the best possible host we could give. But we had some difficulties yesterday, and without giving you such a smooth and relaxed audience, it wouldn't be possible to overcome all this and to make the atmosphere like it was. So that a lot of thanks also to you for being the best possible audience. We were happy to have you here, yeah, we have already thanked all these organizations. So, wolltest du noch was sagen? Gut, dann so we can close the conference right now, and we'll be happy to open the next conference next year. We're planning to do about the same, but even better. Thank you.